डॉक्टर बाली डॉक्टर साहब
हाँ देखिए मेरी फोटो तो इधर है ना, मेरी फोटो तो इधर है ना।
हाँ जी
मेरी फोटो
ਜਾਏਗੀ ਹੁਣੀ ਉਧਰ ਜਾਊਗੀ ਜੀ, ਜਾਊਗੀ ਜਿੱਦਾਂ ਤੁਸੀਂ ਸਾਰਿਆਂ ਨੂੰ ਹੁੰਦੇ ਪਏ ਸਾਬ ਹੋਰ। ਆ ਦੇਖੋ ਡਾਕਟਰ ਡਿਪਟੀ ਦਾ अच्छा
है ना। डॉक्टर बाली जी
हाँ जी सर
सर
फाइन फाइन बहुत बढ़िया, तुसीं सुनाओ।
मैं बंदियां नूं पहला जूम दी ट्रेनिंग कराया करो भी कित्थों म्यूट होना ते कित्थों अनम्यूट होना, कित्थों वीडियो
हाँ, अपनी फोटो दे ऊपर राइट ते जाओ।
मैं बाकी
नहीं हुण मैं समझा दिंदा, राइट ते जदों तुसीं जाओगे उत्थे ब्लू दे विच आ जाना म्यूट।
कनाडा दे
ਤੇ ਹੋ ਗਈ ਗੱਲ ਉਹ ਹਨਾ ਸਾਡੀ, ਤੇ ਉਹ ਚਲੇ ਗਏ ਨੇਗੇ, ਉੱਥੇ ਪਹੁੰਚ ਗਏ ਨੇ, ਉਹ ਕੈਂਪ ਤੇ ਪਹੁੰਚ ਗਏ।
जी गिरा देखो अपन अदालत इस मेरे पीडी अपन ग्रेड पर
पता ही एक स्टेट हो गया बाद अपन तो वीडियो
अपनी आवाज
पासवर्ड नहीं प्रोफाइल पासवर्ड वाली कितने रुपया का मुकुल बन गया ठीक है वो पैसे नहीं जान फिर मैं चेक ही लेता हूं।
हाँ मैं भी कट के रखे चेक जाना ठहर के। हाँ आ जाने
अभी तो नहीं आया
अभी तो नहीं आया। वो नरेंद्र आया मेहरबान जान
कोई मीटिंग चल रही है। तो मैंने दवाई लिख के देना है पहले मोग हटा फीड मैनू
मेरा फोन नंबर ले जा,
फोन नंबर ऐसा तो मेरे पास है।
मैं लिख भी दूंगा। गोली नहीं पाउडर अद्धा अज दे दी, 3 हिस्से वंड ली डब्बी में, एक हिस्सा अज एक कल नहीं राम है
अपनी
है।
लवदीप सर अपनी आवाज में म्यूट करो। लवदीप सर अपनी
ऑनलाइन ट्रेनिंग है। अच्छा कोई गल नहीं, तो मैं
30,000 आ गई जी रूट पे होगी पौनीगढ़,
ठीक है।
आगे नहीं पता 15,000
मतलब अपनी आवाज तो नहीं जा रही ना।
विकास आ कपड़ा लगे
डॉक्टर जसपाल तो भी गया, डॉक्टर जसपाल ने घाटा नंबर दिता बंदा गांव दी बहुत पिछा मारती है जी, पिछा मारती ना बहुत ज्यादा मारती टंका लाना पऊ है बनाए चल गए थे पता तो पई है जे टंका लाना होए तो नीडल पई है टंका दसूगा हैगा आज कितनी तरीक ਆਪਾਂ ਨੂੰ 6 7 7 8 9 ਦੀ ਛੁੱਟੀ ਹੈ बस याद के दे दें
यार देखो मैं इधरों म्यूट करा
कर
Very good morning to all of you. So it is a kind request to all of you to mute your microphone so that it will be going into the native. So hope that everybody has muted their microphones. So we are starting the meeting. So before starting the meeting, we have shared the YouTube link in the chat box. So you can share with your colleagues so that they can also attend this meeting. So we will start the meeting today. So respected dignitaries of the day, the veterinary officers from Punjab, scientists of ICAR-NIVEDI, and dear friends, a very good morning to all of you, and we are really fortunate enough to have you all here with us today through virtual platform for the awareness program on SeroMonitoring of CSF-CP under Livestock Health and Disease Control Program, jointly organized by DAHT Government of India, New Delhi, and ICAR-NIVEDI, Bangalore. And we, the Nivedi family, extend a very warm welcome to all of you to this meeting. So let us start today's program with ICAR song, which is a video depicting the importance of Indian Council of Agricultural Research. May I request Ms. Arpita to play the ICAR song.
बुला रहे हैं उनका मीटिंग चल रही है
Thank you so much, Arpita. Actually, sound was not audible to us. Sorry for that. So now it is my proud privilege to welcome all of you to this awareness program. I take this opportunity to welcome Dr. B.R. Gulati sir, a director, ICAR-NIVEDI, and Dr. Ranjiv Bali sir, joint director, NRDDL, Jalandhar, Punjab. Sir, welcome both of you to this meeting. We are having most distinguished speakers for the day, and I, on behalf of the organizing team, welcome all of you, starting with Dr. Parvinder Kaur, Assistant Director, NRDDL, Jalandhar, Punjab, Dr. Gursimhan Philia, Principal Scientist, College of Veterinary Sciences, Gaduwasu, Ludhiana, Punjab, and a team of scientists from Nivedi, starting with Dr. S.S. Patel sir, who is the nodal officer for the CSF-CP program, and sir is the principal scientist in ICAR-NIVEDI. Dr. K.P. Suresh sir, principal scientist, Dr. Jagdish Iramat sir, senior scientist, Dr. Shivasharanappa sir, senior scientist, Dr. Narayanan G, senior scientist, and Dr. C.S. Sadish Gowda, scientist. So I, on behalf of the organizing team, welcome all of you to this meeting.
Siju, unmute, please.
And you have muted yourself. Please unmute.
Yeah. It was not audible, sir.
It's okay.
Now it is audible, please.
Okay.
Audible.
Should I start from beginning, sir?
No. Okay, go ahead.
Okay. So I, on behalf of the organizing team, welcome all the veterinary officers of the Punjab state, who are the key players of this control program, and for the success of this control program definitely depend upon your effort. Welcome all of you to this meeting, and the scientist of our NIVEDI is also attending the meeting, so I welcome all of them to this meeting, and thank you so much for this opportunity. So moving to the next program, may I invite Dr. B.R. Gulati sir, Director ICAR-NIVEDI, for giving the opening remarks.
Thank you, Dr. Sizu. Dr. S.S. Patil, the Chief Organizer of today's meeting. Dr. Rajiv Boali, Joint Director, NRDDL Jalandhar. Dr. Gursimran Philia, Civil Scientist, Gadwasu, Ludhiana. All the scientists of ICAR-NIVEDI who are organizing and participating in this meeting, and dear delegates from Punjab and other places who are attending this important awareness program on SeroMonitoring of classical swine fever control program for its effective implementation. I welcome you all in this meeting, and I would like to say that this meeting is really a beginning first step for contribution of all of you in the control and eradication of classical swine fever from the country. So coming to the pigs, they are one of the important animals in many states of India, especially the northeastern part of India, where the 40% of the 9.06 million pig population resides, and then some other states in northern India, including Punjab, where pig is playing important role in livestock economy and also in providing the nutritious requirement of the human population, which is always increasing. So nutritional needs are always on the rise. So pigs definitely plays important nutritional role for the population, and in that we are facing that during last 1 decade or so, many diseases are emerging, whether they are existing endemic diseases which are on the rise or new transboundary animal diseases which are coming. We have experienced many disease outbreaks, including swine influenza, swine flu, or recently we are facing the African swine fever, which is devastating disease and has almost destroyed the swine industry. The pig farmers, they are suffering a lot, and because there is no vaccination for African swine fever, the government and the livestock owners, they are not able to do many things because they are not trained and informed about the other ways to prevent such kind of transboundary animal diseases. So coming back to classical swine fever, again, this is an endemic disease in our country and causing a lot of morbidity and mortality in swine industry. And considering this is again a viral disease, which is caused by a pestivirus. In this pestivirus, there are other important viruses also like bovine viral diarrhea or the border disease or Hobby-like viruses, and belonging to this family Flaviviridae. So this is an RNA virus, and fortunately for this disease, there are vaccines available. So where there are control measures available, then effective control strategies and control mechanisms can be put into place. But there are certain areas where there are gaps where we can contribute. And one thing that plays a very important role in control of classical swine fever is the biosecurity measures implemented both at the farm level as well as at the feed level as well as the border level. Biosecurity, along with slaughter or culling of infected animals and suspected pig herds. This is one of the most important strategy for any disease control, whether it is classical swine fever or whether it is African swine fever. This is the one of the most, but then we have to see that when we are doing such biosecurity measures, the proper disposal of the carcass, proper steps taken of disposal of the carcass are important. Otherwise, the contaminated meat and or infected carcasses can be another source of infections. Then we need to have, besides biosecurity steps, we need to have reliable disease diagnosis and disease reporting. This is where all the veterinarians working in the field play a critical role. So timely reporting and timely contribution of sending the samples to the recognized laboratories for timely diagnosis of the disease is very critical in controlling the disease as well as in eradicating the disease. So this is another area where your role is very critical, and Dr. Patil and his team will be talking about how you can contribute. Then another area is the vaccination. For this disease, there have been vaccines available. Previously, we used to have the lepinized live attenuated vaccines for classical swine fever. Nowadays, we have the cell culture based live attenuated vaccines, which are very effective and given the one shot gives long-term protection. So implementation of vaccination program again is the role of field veterinarians. They play a very critical role along with the state animal husbandry administration. The role of field frontline workers, including the veterinarian, is very critical. So these are the areas. And once you are doing the vaccination for this classical swine fever, fortunately, the government of India has launched nationwide control program under livestock diseases control program. So wherein the vaccine is being provided by the government of India free of cost to all the states for 100% vaccination. And we are targeting, the government of India is targeting this disease will be controlled by 2030. So this is one of the important target for all of us, controlling and eradicating classical swine fever from India. So for this, vaccination is important, and then monitoring of success of vaccination, that is very important. So this is where NIVEDI is playing important role in surveillance and monitoring of the classical swine fever infection, as well as the monitoring of success of vaccination program. So what in today's deliberations, the team of NIVEDI, led by Dr. S.S. Patil, will be talking about how successfully we have to implement this program. We are already providing the sampling frames and sampling plans for each of the states, and at the district level, at the village level, the sampling plans have already been in place. You will be playing critical role in collecting the samples as per the sampling plan, and then maintaining the cold chain, sending the samples to the NIVEDI so that we can effectively monitor the success of vaccination program. Also, we can also monitor the surveillance activities and how much is the virus load available in the field, what is the level of infection, and what are the midterm corrections that are to be taken by the government of India to meet the targets of eradicating classical swine fever from the country. So with that, still we need to do some researchable issues also. We have diagnostics already available with us for detecting the antibodies. But since the vaccination program is going on, we need to have some assays which can differentiate between the infected pigs and vaccinated pigs. So that kind of DIVA assays that need to be developed. And then what are the durations of the vaccines, how long they give the protection, whether the vaccinated animal and response of the host, the pig animals, vaccination response, how much is there, we have to monitor, and we will be contributing in doing that. with this in background, I would like to thank once again all the participants and congratulate the organizers for organizing this meeting, where there is so much of response that all the Zoom meetings participants list is already complete, and then you have to create the YouTube link for the remaining spillover participants. So once again, I wish you all the best. Thank you very much.
Thank you so much, sir, for providing a brief overview about the disease, classical swine fever, and the crucial roles that need to be played by the field veterinary officers for the successful implementation of the control program. So thank you so much, sir, for your valuable time. So moving to the next program, we are having with us Dr. Ranjiv Bali, sir, Joint Director, Northern Regional Disease Diagnostic Laboratory, Jalandhar, Punjab. May I request Dr. Ranjiv Bali, sir, to address the gathering. Sir, please.
Good morning to everybody. I welcome all the participants attending this online meeting regarding classical swine fever scenario in Punjab. I am highly thankful to Dr. S.S. Patel and team for organizing this meeting. As we all know that our livestock industry is being threatened by various new emerging diseases. Recently, we have seen the outbreaks of lumpy skin disease and African swine fever in various parts of the country. These diseases have caused heavy economic losses to the livestock farmers directly, and most of these diseases are viral. Hence, there's no specific treatment for these diseases. By adopting strictly biosecurity measures and vaccination programs, these diseases can be controlled. Up till now, Punjab is free from CSF and vaccination has conducted on large scale. I hope with this meeting, your knowledge regarding CSF will be refreshed and updated, and we will know every aspect of the disease in detail. Thank you.
Thank you so much, sir, for your kind words and for sparing your valuable time with us. Thank you so much, sir. So now may I request all of you to kindly switch on your camera so that we'll take a group photo. So kindly switch on your cameras, please.
कपड़े हटाओ तो लग रहा है कि हॉस्पिटल है कहाँ तक कपड़े टंगे पे उठे कट्टे कैसे पर्दे लाने में हाँ
Gallery, you mean gallery and take, no? You are making gallery and taking camera out.
So thank you so much to all of you. So we will move to a technical session. Our first session will be on overview of classical swine fever in Punjab state, and that will be delivered by Dr. Parvinder Kaur sir, Assistant Director, NRDDL Jalandhar, Punjab. May I request Dr. Parvinder Kaur to share the screen and start the presentation.
Good morning, Dr. Parvinder.
Good morning, everyone.
Good morning, Dr.
Good morning, respected senior scientists of NIVEDI, Bengaluru, and my colleague fellow vets from Punjab. Good morning to Joint Director NRDDL. Myself, Dr. Parvinder Kaur, Assistant Director NRDDL. I am presenting overview of this classical swine fever in Punjab. First of all, I will tell you about the population of pigs in Punjab. We have maximum pig population in Sahibzada Ajit Singh Nagar and Ludhiana, followed by other districts. And we have total pigs population in Punjab according to 20th livestock census, that is 43,290. And due to African swine fever, which attacked Punjab or even northern India in August 2022, due to this, in Punjab, overall, we have reported 24 epicenters and 12 districts of Punjab are affected with African swine fever. Due to this fatal disease, the population of pigs have drastically reduced, and presently we have 38,500 pigs in Punjab, and we have approximate 400 private pig farms which are organized, and we have 5 government pig breeding farms in different districts of Punjab like Hoshiarpur, Gurdaspur, Firozpur, Kharad and Nabha, and we have 1,700 breeding animals, breeding pigs, 4 and sows in these government pig farms. And we have large white Yorkshire breed in Punjab. Now, the incidence of classical swine fever in Punjab, till date, we have not reported any outbreak of classical swine fever in Punjab. In last year, various districts of Punjab reported mortality along with various clinical signs resembling classical swine fevers in pig population. And a total of 35 classical swine fever suspected samples were sent to Cadre at Bareilly in 2022, but all these samples are tested negative for classical swine fever. And we have sent these samples to Nishad Bhopal for African swine fever, and they are found, all samples they are found positive for African swine fever. So this is the impact of classical swine fever. Like in acute form, there is high mortality and productivity losses. There is losses in the term of treatment, the cost of treatment, and the production of animals. Now, Director Sir NIVEDI told about the disease, that it is a fatal disease, and in this disease, there is high fever and gastrointestinal symptom and general weakness, conjunctivitis, hemorrhages, cyanotic skin lesions, leukopenia, leading to heavy mortality and substantial economic losses in pig industry. And Sir also already told that this disease belongs to Pestivirus family and Flaviviridae, a small RNA enveloped virus, and the disease can affect pigs of all ages. All young and old and grower pigs are affected with this classical swine fever, also known as hog cholera. And another point is the disease is also notifiable. And the disease has 3 different forms. The acute form having mortality up to 100%, subacute form low morbidity and mortality rates, chronic few animals affected, and it is always fatal, and some cases are asymptomatic. Now the transmission, as we all know, the virus is secreted through blood, saliva, urine, feces, and tissues. And the transmission of the disease is through ingestion of contaminated garbage, like swill from non-veg hotels and non-veg messes and the kitchen waste and the meat product, and also via direct and indirect contacts. And some very important clinical signs of the disease are huddling. The pigs gather together and they sit with close contact because they are feeling cold and shivering due to high rise of temperature. And next, very important, all field veterinarians should note that the disease have in this, there is very important clinical sign that also resemble with many other diseases like ASF also, PRRS and other the blue ear disease. The resemblance of clinical signs are the cyanosis of the ear tips, now the cyanosis of this snout, tongue, and lower legs. These are the very important clinical signs. Next is, this is melena due to hemorrhagic lesions in stomach of the animal. That is the sign of this bloody diarrhea, also known as melena. This is also very important clinical sign in CSF. And in case of subacute disease, the similar to acute form, but symptoms are less severe. Pigs may survive. And in chronic form, anorexia, depression, fever, diarrhea. These are the important clinical signs. The poor reproduction performance, including abortions, stillbirths, and deformities in the piglets. These are the clinical sign in chronic form. And now come to the post-mortem lesion. If pig are laid on their back after death and open for examination, the findings are like there are usually many small hemorrhages throughout the body and a larger hemorrhages in some organs such as lymph nodes. Some of these may be bright red and filled with blood, and there are hemorrhages in particular form on the lungs and under the skin. This is very important clinical sign, post-mortem lesion, the hemorrhages in lymph node. The lymph nodes are like mesenteric lymph nodes, the lymph nodes, renal lymph nodes, gastrohepatic lymph nodes. We can see these type of hemorrhages. Now the hemorrhages, particular hemorrhages on lungs, and the kidney looks like mottled duck egg. Another very important to note is the spleen may have dark raised areas of dead tissue. Similar areas of dead tissue occur in other organs, for example, tonsils. Tonsils we can found on the submandibular area of the pig. We can extract the tonsils. These are of thumb size, first digit of the thumb size having raised portions. And tonsils are very important to find, and these are very good sample for the detection of classical swine fever. And this is petechial hemorrhages on the kidney. This slide is very important and have all pathognomonic lesions like the discoloration, the dark color of, and the spleen is enlarged, having dark color, dark bronze color, and liver is also dark and friable, and abdomen have blood. In abdominal cavity there is blood, and the intestines are congested. This slide is very important. This slide gave us the idea that this animal is suspected for CSF or ASF, and confirmation by laboratory test. Now, the stomach and gut are usually empty except the scant liquid, which may be brightly colored. Fairly unique lesions to look for are raised so-called buttonule cells. These are also very important lesions which are located at the junction of small intestine with large intestine. These are the button ulcers. These are the button ulcers. Now the sample for lab, as we know that the diagnosis is from clinical signs, from postmortem lesions, and laboratory result. From all these three results, we can make the diagnosis that the animal is suspected with, or animal is positive with CSF, having disease CSF. And in case of live animal, we are to send the blood, that is whole blood, in blue capped vial, and we are to take the blood of the animal from the ear vein very easily with scalp vein. And second sample is spleen, liver, tonsil, and spleen and tonsil are the very good samples for the detection of classical swine fever. And we are to take these sample as early as possible, label them properly, and send them to the lab on ice. We are not to add any additive, any preservative in the samples. And the diagnosis of the disease is based on clinical signs, postmortem lesions, and the laboratory findings. Next is differential diagnosis. We can differentiate from the disease, from classical swine fever, from following disease. First is how we can differentiate clinically from African swine fever. How cholera-infected pigs or CSF-infected pigs are depressed and lose weight, whereas in ASF, infected pigs have neither symptoms. How cholera is also characterized by foul-smelling diarrhea. In case of CSF, there is foul-smelling diarrhea, and in salmonella-infected pigs, there is also salmonella diarrhea. There is also smelly diarrhea, but in the diarrhea, there is blood and mucus. In erysipelas, there is skin lesions, but these skin lesions are of different shape. We can differentiate very easily. These are diamond-shaped lesions. And another reportable and very different disease of swine industry, that is porcine reproductive respiratory syndrome, PRRS, is also known as blue ear disease. In this, the younger pigs are infected with the blue ear disease, and this blue ear symptom is for transient period, right? Next, prevention. Prevention is do not feed uncooked garbage, that is swill. Do not feed swill from non-veg hotels or non-veg kitchen. And another is minimize visitor in the farm and follow the biosecurity measure like clean the disinfect the areas properly. Next, very important is to monitor the animal for illness or sign of the disease, like inspect the animal daily, report sick animals, and isolate. This is important to note, isolate healthy animals immediately from sick animals. Then quarantine newly imported animals, introduced animals, minimum for 30 days, and keep health record of every animal. Next, control. Control is with vaccination. We are lucky that we have vaccine, and our institute, Punjab Veterinary Vaccine Institute, under Animal Husbandry Department, manufacturing this vaccine for classical swine fever, and that is why we have controlled this disease with the help of this vaccine. And now the vaccine is provided by Government of India under NADCP program. The dose of that vaccine is 1 ml, and the vaccine is this Raksha class. and the dose is 1 ml. The route, kindly note, the route is intramuscular route in the of the Raksha class vaccine. And now the control is for surveillance and monitoring plan for control of classical swine fever has been formulated, and that has started to be executed in Punjab state, under which all pig population above 3-month-old will be vaccinated against classical swine fever yearly. And baseline survey, we have collected the with the help of our field veterinarians, we are able to collect the pre-vaccine samples of the age of 3 to 12-month-old pigs. And for seromonitoring, after that, those are post-vaccine sample, the time is 30 to 50 days after vaccination, and the age group is 4 to 12 months of age. And from above districts or from all over Punjab, all 22 districts of Punjab, we are able to collect 669 samples, the pre-vaccine samples, and a few districts, only 3 districts have sent post-vaccine sample. And the status of the population, status of population. What is the Gaurav? What is this? Screen. I think this is status of classical swine fever vaccine. Like in all 22 districts, we have distributed, like we are having approximately 38,000 animals. And we have procured 22,820 doses of classical swine fever vaccine. And we have vaccinated till date 19,472 animals, and only 3,348 doses left with. And the farmer benefiteds are approximately 394. This is all about the status of classical swine fever and scenario of classical swine fever in Punjab. Thank you. Thank you very much.
Thank you so much, Madam, for the elaborative and informative presentation. Madam was giving an overview of classical swine fever, starting with clinical signs, PM lesions, lab diagnosis, and all the aspects of CSF in a very crispy manner. Thank you so much, Madam, for sparing your valuable time. Thank you.
Thank you. Thank you very much.
Yeah. So moving to the next presentation, we are having Dr. Gusimran Philia, Principal Scientist, College of Veterinary Sciences, Gadwasu, Ludhiana. He'll be talking about research on classical swine fever in Punjab. May I request Dr. Gusimran Philia to share the screen.
Philia presentation देन लगी है. तेरी फिलिया मैडम प्रेजेंटेशन देने लगी है.
Madam is also co-PI of our Naden Center under ICAR-NIVEDI. Welcome, Madam.
Good morning to all. Good morning to all my colleagues at Nivedi and all the field veterinarians of Punjab. Today, my topic of discussion is the research on classical swine fever in Punjab. As already discussed by other speakers, I'll give us a very short introduction for the classical swine fever, which is caused by the pestivirus from the family Flaviviridae, and it is structurally related to the bovine viral disease viruses and the border disease viruses. It is extremely contagious disease, which is characterized by fever, hemorrhages, leukopenia, abortion, and high mortality. According to World Organization of Animal Health, they have kept the disease in the list of reportable disease. And the result of this is that there are trade sanctions in the countries which are affected with the disease. In India, classical swine fever is one of the top 5 economically important viral diseases of livestock, along with the sheep and goat pox, blue tongue, FMD, and PPR. The transmission is both horizontal as well as vertical. So in horizontal transmission, the disease is passed on from the pregnant source to the young ones, whereas in the it's just reverse. It is in the vertical case, the disease is transmitted from the pregnant source to the infected piglets and to the piglets, and these piglets, when they are born, they are infected and they are slowly shedding the virus. In case of the horizontal transmission, it is as a result of the various infected secretions like the saliva, lacrimal secretions, urine, feces, and the semen. Then there are 4 forms of the classical disease and forms of the disease, and these are the peracute form. In the peracute form, the infection, there is high morbidity along with high mortality, and there is death within 4 to 10 days of the post-infection. In case of the acute cases of the disease, the death is from 10 to 20 days of the days post-infection, whereas in chronic cases, it is from 21 to 30 days, and in case of the chronic, it can be after the 30 days the death can occur. However, in few of the clinical cases, chronic cases, it's not that the death will occur, but the infected animals, they will continue to shed the virus. The virus, it can also survive in the pork and the processed pork products for months when they are kept in the refrigerator, and they can also survive for the years, many years, if they are kept in the minus 80 degrees temperature or at the minus 20 degree temperature. So now coming to the research which has been carried out in Punjab related to the classical swine fever. First of all, there is a development of the antigen captured enzyme linked immunosorbent assay for the diagnosis of classical swine fever has been carried out. In this case, the E2 gene of the classical swine fever virus was cloned in the laboratory in the modified insect cell expression vector for producing the recombinant protein in the secretory form. And this recombinant plasmid, which was prepared from the positive clone, it was transferred into the high 5 insect cell line, and the stable cell line was developed. This stable cell, high 5 cell line, it was successfully, from this, it was E2 recombinant protein was successfully secreted, and this was verified by the SDS page and by the Western blotting. In addition to this, the recombinant E2 protein, it was raised in the hyperimmune sera was raised in the rabbits and the chickens. This rabbit and chicken raised hyperimmune sera, it showed good reactivity to the classical swine fever vaccine virus as well as to the recombinant E2 protein. So these are the pictures in which they are showing the SDS analysis of the E2 protein was carried out, and the second picture shows the Western blot assay that was carried out for the confirmation of the classical swine fever virus E2 proteins. In addition to this, the antigen captured ELISA was optimized using the chicken raised hyperimmune sera as the captured antibody in the dilution of 1:80, rabbit raised hyperimmune serum as a detector antibody at the ratio of the 1:800 dilution, and the anti-rabbit HRPO conjugate as secondary antibody. So developed this antigen captured ELISA, it could successfully differentiate between the tissue samples which were infected with the classical swine fever virus from that of the negative samples. And in addition to this, it has been seen that large number of positive and negative samples of the classical swine fever virus are required to be tested to determine the sensitivity, specificity, and further validation of the assay. So this is a picture showing the different dilutions of the E2 recombinant protein which were carried out to standardize the ELISA. And this is the picture representing the optimization of the dilution of the rabbit or the chicken hyperimmune sera which was raised and was used for the development of the ELISA. So the other study which was carried out is related to the molecular characterization of the structural genes of the classical swine fever. So in this, the cloning and the sequencing of the core and the glycoprotein genes was carried out. The core protein, it plays an important role in the viral structure and regulation of the gene expression, whereas the glycoprotein, it takes part in the initial attachment process of the viral entry. So a total of 17 tissue blood samples were collected from the dead piglets suspected of the classical swine fever virus, and out of this, one sample was positive by PCR. Further, this E gene, that is the glycoprotein gene, and the core protein of the positive samples were amplified, they were cloned and sequencing. And from the sequencing, the results, they indicated that the Punjab isolate virus, it belonged to genotype 1.1. So this is a picture representing, photograph representing the recombinant colonies of the core protein and the glycoprotein. And the second picture is that of the agarose gel electrophorese for the screening of the recombinant protein, recombinant clones of the core protein gene and the glycoprotein gene by the colony PCR. So in addition, as already said by Dr. Patil, we are the member of the NIVEDI team for the in one of the projects. So in this, we are attending the outbreaks in Punjab since last many years, and this is the data of the last 10 years which we have recorded. It has been seen that during the total of 20 outbreaks were reported in a period of 10 years. And in the initial years, the number of outbreaks was more as compared to the number of outbreaks in the recent years. So this is a table which is depicting the number of outbreaks that were attended by the Gadwasu team, and the most of the places in which the outbreaks occurred were mainly the Ludhiana district, Bathinda district, Patiala, Ropar, Firozpur, Bathinda, and Muktsar. So in the year 2016 to 2017, 2 outbreaks of mixed infection of the classical swine fever along with the porcine reproductive and respiratory syndrome disease were reported, and 1 each from Patiala and the Mohali districts. The diagnosis of all these outbreaks are depicted in the table, and they were mainly on the basis of the clinical signs carried out, the postmortem lesions that were observed, or by the PCR, then by the antigen ELISA also was carried out. So by this diagnosis, these techniques, the diagnosis was confirmed. So these are the pictures of the samples which were observed during the postmortem. That is, in the first picture, we can see the piglet which had died due to the classical swine fever. Then the spleen is affected, liver, lung, and the kidneys of the animals, they were affected. So the following publications were made from the research which was carried out. Dika et al., they carried out the seroepidemiological study on the porcine parvovirus, circovirus, and classical swine fever infections in India. And in this, they collected approximately around 1,308 sera samples from 92 different pig farms covering 8 northern states, northeastern states, and Punjab. During 2 periods, that is from 2011 to 2013. And from the northeast, the regions covered were Assam, Arunachal Pradesh, Meghalaya, Manipur, Mizoram, Nagaland, Tripura, and Sikkim. And in Punjab, the districts which were covered were Ludhiana, Jalandhar, Patiala, Amritsar, Moga and Fazilka. So in Punjab, the seroprevalence of the classical swine fever vaccine in the non-vaccinated animals was 44.4%, while in the vaccinated animals, it was 22.36%. Another study was carried out by Kumar et al., and they carried out the study of the concurrent pustulosis and classical swine fever in Indian pigs. So a total of 4 outbreaks from different 4 herds of Punjab, they were attended by the team, and their overall morbidity, mortality, and case fatality rate were 88.2%, 77.5%, and 87.8% respectively in pigs less than or equal to 3 months of age, while it was less, the figure of morbidity, mortality, and case fatality was less in case of the older piglets. In 2 of these such outbreaks, there was the mixed infection with that of the pustulosis. So from the samples that were brought to the lab, the Pasteurella multocida isolates, they were obtained, and then by PCR they were further confirmed by the team. Thanks.
Thank you so much, Madam, for the beautiful presentation on research on CSF in Punjab. Madam was mentioning about the developed ELISA, molecular characterization of the virus and outbreak diagnosis, and the research leads that have happened in Punjab. Thank you so much, Madam, for sparing your valuable time with us. So kindly mute. So moving to the next lecture, we are having with us Dr. S.S. Patil, sir. Sir is the nodal officer of CSF control program ICAR-NIVEDI, and sir is having a lot of experience in working in classical swine fever. And sir's experience will definitely play a crucial role in implementation of this control program. So today, sir will be taking the lecture on seromonitoring of CSF during implementation of the control program. May I request Patil sir to share the screen and start the presentation.
Thank you, Dr. Shizu. Thank you very much for your anchoring and also introduction for nice words. Am I audible?
Yes, sir, you're audible, sir.
Yes, just a minute. I'm sharing my this one. Just stop it.
Full time pass करो. बंदा ना अपन.
Yeah, Shizu, it is visible.
Sir, your presentation is not visible. Only that folder is visible.
Still not done. Now, not it.
No, sir. Only the folder is visible.
Okay. Sharing. Your screen.
Stop share. Screen. Share
Desktop. Now, Shizu?
Not that, sir. I think you can unshare and once again you can share.
Yeah. Just share.
Unshare ಮಾಡಿ.
Yeah, unshare. Yeah.
One screen.
Now?
Sir. Now it is visible, sir.
Yeah. Good morning. Yeah. Good morning, everybody. Respected. Please mute others. Please mute it. Respected Director Dr. B.R. Gulati sir, Ranjiv Bali sir, Parvinder Madam, and Philia Madam. Please mute others. Parvinder Madam, Philia Madam, and all my colleagues of NIVEDI and respected veterinary officers of Punjab State. It was a very good informative lecture by Parvinder Madam and Philia Madam. as per the Parvinder madams, there are depletion or deletion of 14,000 pigs in the Punjab state due to ASF alone. And one more hardening thing is that you have not noticed any outbreaks, classical swine fever outbreaks during the last year. As per the Philia madam's report, 21-22 was the last outbreak. And now one aspect is you have to be very, very careful, because you share the borders with many of the other states who are reporting the disease. And it is your duty now not to allow the classical swine fever into your state by vaccination and keeping alert and monitoring continuously. As per upon various deliberations, we have discussions at various platforms with various experts and stakeholders. We have prepared an action plan for surveillance and monitoring. As our director also said, SeroMonitoring is a very important and critical aspect of after vaccination. Once the vaccination is done, monitoring of the antibodies development is very important and a critical part. So in that aspect, we have prepared an action plan, and I will be presenting in front of you. If you have any queries, please put them in the chat box, as there are many participants and we have another program after this. Or else you please put your queries to Gagan Deep Madam. I have shared, and you must be having her email ID also. In turn, she will share with us. We have a team consisting of Dr. KP Suresh. He is a principal scientist and sampling plan expert. And we have Dr. Jagdish Hiremat. He will be talking on outbreak investigation with special reference to classical swine fever. And we have Dr. Shivsharanappa. He will be talking on post-mortem examination. Dr. Jagdish will also speak on biosecurity aspect of the disease. And we have Dr. Narayanan. He will be talking on response to CSF outbreaks, capturing social networks of pig movements, vaccination, and trade. And we have with us Dr. Satish Gowda. He will be collecting and telling you how to collect the information for the assessment of the economic loss. We have Dr. Sridevi and Dr. Chetan Kumar, and they will also be joining in subsequent time. Coming to the action plan for this, as already we have discussed in detail about the total pig population, over the last 3 census, if you look at it, we have the depletion or reduction in the pig population. There were 11.13 millions of pigs earlier, all over India status. Then next census, it came down to 10.23. After that, now the present scenario is 9.06 millions of the pigs. And it is decreasing in Punjab also. Either it is attributed to the infectious diseases or not supported by the policymakers, the pig industry. The total reduction is 12.03 as a whole for Indian scenario of the pig industry, what we can say. This is about the pig population. And these are the top 10 these are the top 10 states of India wherein you can find the highest number of the pig population, and Karnataka stands 9th in this category. And again, if you look at this one, there are hundreds. You can see Chandigarh, Gujarat, Pondicherry, and in thousands you can come down to Jammu, Kashmir, Himachal Pradesh, Uttarakhand. Afterwards, you can see the pig population is increasing, and Assam will have around 20 lakhs of the pig population. As per the census 2003 and 2007, Punjab population, this I got it from the census. We have a crossbred population, indigenous population, and 12 to 19, there is a reduction of 3.01% of the pig population. And latest, as told by Dr. Parvinder Madam, there are actually we have 52,000 in our census data, and Madam told around 45 to 48,000. And in that only we have a reduction of 14,000 of pigs last year alone due to ASF. And these are the districts of different pig populations of different districts. In the left side, you can see. Coming to the testing part, the ICAR-NIVEDI has developed its own indigenous kit using indigenous virus. eRNS is a secretory protein of the classical swine fever. We have expressed it in prokaryotic system, and using that as an antigen, we have developed indirect ELISA for detection of the antibodies. That is the reason we are collecting pre and post vaccination serum samples for assessment of the seroconversion in the population. And we have tested the validation is also done at different centers like Izzatnagar, Tanwas, and IVR Bangalore, and Bhagpat, and elsewhere also. And the cost per sample is works out to be very less. That is rupees 40 per sample, as against more than rupees 125 per sample of the imported kit. And sensitivity specificity is 95 and 97%. And the kit was released by the Honorable Minister of Agriculture during the COVID period. It was virtually released on the 6th of July 2020. And as per the calculations, Kappa value agreements, it is working very good agreement with the gold standard methods. So during the control program, one has to be very careful. As we are seeing, our farmers are keeping the pigs along with some other livestock also. So there are likely chances of spillage of virus, especially during the control programs, or as far as the Punjab state government is concerned, there is no outbreak of the disease, then where virus can get escape into the environment, likely chances of getting into the other livestock. There one has to be very careful in monitoring of the movement of the virus. So by collecting the pre-vaccination serum, we can have the baseline antibody level in the population. And what is the year-wise progressive response of the animal to the blanket vaccination, one can understand. And what is the progressive herd population or population immunity level in the time series manner, that is during the 5 years program. And what is the status of outbreak of the disease during the control program. That gives an idea about the spatial epidemiology at village level, taluk level, district level, covering the entire India to define the true hotspots. What is the changing pattern in terms of course of clinical disease, and including the strain variation, if there are any, and during the period of control program. And progressive status of infection or disease in other unusual host during the program. This is very important. Once the pigs are free, they have the antibody level, population herd immunity is maintained, then likely chances it may shift into the other livestock animals reared simultaneously along with the other pigs. Then what is the progressive syndromic or clinical surveillance? There are areas, especially in the northeastern states, where the pig population density is very high. We have to be very careful in observations through clinical surveillance or through collection of the information by survey methods. What is the herd immunity level at the end of the 5 years of vaccination in pig population? That we have to answer it. And what is the level of lab competency increased in all the participating laboratories? Now we have to decentralize the testing facilities to all other capable laboratories, so that they can do on their own, because the control programs, as they proceed and advance, they will ultimately they should culminate into eradication programs. Then the local or the state level laboratories are to be equipped, and they have to develop their own competency. And what is the change in the level of the awareness between the beginning and the end of the period? Some people may get retired, or the youngsters which are staying for a long time, they have to come out with their own ideas and the programs in understanding and implementing the control programs. Finally, what is the economic impact by undertaking, whether it got benefited to the farmers, and the control programs are really successful? All such questions are to be answered. Points to be remembered, and we have to ponder over on this one. Immunity or antibody response due to infection, it is decreasing over a period of time. Due to infection, antibodies should go down, and vaccine response, because of which the high immune response should be there, and there should be uniformity in the antibody level and herd immunity in the population. And herd immunity, it keeps on increasing as we keep on vaccinating yearly. And never to be neglected, surveillance in the wild boar and unnatural host. Likely chances that we are left, or the wild boars are not covered under vaccination, as the accessibility is a problem, and sometimes they may escape also. And we neglect the unnatural host, like as I told, the cows, the bulls, and some small ruminants, they are reared along with the pigs sometimes, and we have to keep the surveillance on them also. Sir, we are going in this fashion, like surveillance and monitoring, and outbreak investigation, surveillance in other unnatural host or unusual host, syndromic surveillance. This is in a nutshell, the stepwise program keeps on moving like this. And other activities, like as we receive the data, the samples are tested here at ICAR-NIVEDI, and the huge data will be generated, and the data management is again a challenging task for us. And that should be maintained, analyzed, and communicated, and maintained till the control program is leading to eradication programs. We have a very good statistician, Dr. Suresh, and he will be managing and analyzing the data. Synchronization of laboratories and lab capacity. This, in due course of time, will be taking up. If required, the persons working in the laboratories, they will be trained, and they will be given the kits, and they can test in their own laboratory. Awareness campaign. Now it is confusing with the other exotic diseases. One has to be careful in creating the awareness about the disease, as the state is doing wonderful. Punjab state is doing wonderful job, and they have given a lot of stress and importance. And because you have your own vaccine production in it, you have taken up the vaccination program in a very good way. Now the NADCP, under NADCP, 100% support will be there, and you can again create the awareness campaign for vaccination. As Madam also showed, and this is how the diluent and the vaccine vials are given. And it is told that intramuscular behind the ear, 1 ml deep intramuscular, it is vaccinated. This is a 5-year stepwise program. As we are in the first year, as you all know, the maternal antibodies are depleted 2.5 months onwards. So on the safer side, we have taken 3 months of age of the pigs as the target population. And before vaccination, pre-vaccinal era will be collected, and they will be tested for the antibodies that give. Please mute Sachin Kamboji. Dr. Sachin Kamboji, mute. Yeah, pre-vaccination, before vaccination, you can collect the sera samples and send it to us. We test here, and that gives an idea about the baseline antibody level in the pig population. And about 3 months of age of all the pigs should be vaccinated. And 30 to 50 days after the vaccination, first vaccination, please collect the serum samples. Use internal threaded vials so that there will not be any leakage of the serum samples during the transportation. So 30 days after the vaccination and before 50 days, means 20 days window period is given, because many people are engaged in different activities, and you will not be having much time. that is the reason 20 days window period is given. Between that period, please collect the samples. If you cannot send it to us in immediate days, please put them in the deep freezer and send as early as possible. Already you have collected pre-vaccinal sera 669 samples, and post-vaccinal also some 67 samples are collected, as Dr. Parvinder Madam told us. But don't keep them for a long time. Please send at least the pre-vaccinal sera to us as early as possible on cool packs or ice. Or if someone wants to visit with different activities like PPR serum samples, CSF serum samples, both we are doing here only. Someone can bring it on this one. We have a coordinating center, Nardin Center at Ludhiana. Dr. Philia Madam is the co-nodal officer of our Nardin Center. You can take her help also and pack them nicely. Either you send it by post or someone can bring, if you are planning to bring them all at once. This is the post-vaccinal sera collection. This is how we have told the first year program is like this, and second year and subsequent the program comes like this, and sampling plan is already provided. Dr. Suresh will be speaking on the sampling plan also. As per the sampling plan, if you have any queries, please send it to us through email. We'll be addressing such queries also. Pre-vaccinal sera, again it goes on. This is the continual program, and we keep changing the sampling plan as per the results obtained subsequently. This is 4th year and 5th year, and after 5th year, overall assessment of the herd immunity will be assessed. During the program, pig sera collection, we have provided the SOP along with the action plan book, and it is also available in the website nivedi.res.in. Anytime you can hit that and download the handbook. And transportation, dispatch, and preservation protocol is also provided. And serum is collected in the cryo vials. As I told earlier, internal threaded vials should be used. And if possible, you use the parafilm, nicely pack them. And upon this one, you can make the bundle of a few samples at one and keep them in the polythene covers, maybe belonging to one village or two village or hobli. Like this, you make the bundles of the samples and keep it in a thermocol box, and at 4 degrees centigrade cool packs can be used, and they can be sent to the ICAR-NIVEDI. Testing of the sera samples using our NIVEDI kit, it will be done at ICAR-NIVEDI. And testing of sera samples, that is observed for the pre and post, and we'll be recording the sero conversion through SeroMonitoring. Kits and harmonization, as I told, it will be continual program. This collection of the pig serum samples is this one, as I need not to explain much to the field veterinarians, brother field veterinarians, as they are engaged in the field, and this is refreshing, I can tell. There are various points of the sites of the pig. You can collect the A, B, C, and D. D is the ear vein that many people practice. But in adult pigs, it is collection will be more from the ear vein. The jugular vein is also there. Anterior vena cava are from the heart. Different. This you can see the pictures how the blood samples and internal serum can be separated and sent to us. You all know, I need not explain much on this. Clean the area with 70% alcohol. Locate the vein, and then use this one, and immediately after the collection of this one, allow it for some time, 15 to 20 minutes at room temperature. And if you keep at 4 degrees centigrade for 30 minutes, the retraction will be there, and nice oozing of the serum will be there. And labeling is one important thing that many of us we forget in a hurry, because the moment you collect the samples from the pig, we will all be having a sweating out. And somehow 1, 2, 3 like this we'll write and forget it. Later on, The next day when we come there, we ourselves will forget what is this one, this was farm 2 or farm 1 belong to this farm, that farm, village, this, that and all. Please take out the time. Take out little more time after the collection for labeling. Documentation is very, very important for the analysis part, so that gives a reward to you when you get the results. Transportation of serum samples along with the details. Format is already provided. We have started getting the samples from Karnataka already. The serum separated, collected in cryovals, as I have been telling, the internal threaded tubes are being used, should be wrapped in a cellophane firmly and place them in a pack of multiples of 10 tubes, and then put a rubber band and then send it to us in this one. Such stacked tubes in multiples can be placed into thermocol box with cool ice packs, and sufficient cool pack should be placed depending upon the distance to be transported. Place the thermocol into a carton box, pack them with adhesive tapes, label them, sender's, receiver's name properly, and deposit with the courier agency. And details of the sample sheet may please be kept inside with a polythene cover and send along with one sample. If possible, please share the soft copy of the details of the sample also. And this is the format we have shared, and it is available in the website also. If you want to add some more information to this, that is beautiful, because that will be much helpful for us for analysis part also. And if possible, please add the information when the vaccine was received and when the vaccine was started giving into the animals, means date of receipt of the vaccine and date of injection of the vaccine into the animals. And collection, of course, you are giving the information on collection of pre and post serum samples also. Sampling strategy, Dr. Suresh will be speaking on this one, and sampling plan, sample size, everything he will be dealt with. When you go to the village, you might get confused from where we should start collecting the samples. That he will be telling in detail. This I have taken an example of Mizoram, one block, Sangao block, and in a village. 1 second. Yeah. So in a village under one block of a district, hypothetically divide the entire village into 8 sections if it is very big, and pick the requisite number of the samples from the households from each sections randomly. This is how I have shown one hypothetical example. In a village named Bualpoi NG, block Sangao district, Longwa in Mizoram, a total of 13 pig serum samples to be collected. Like this, I have shown one from this direction, one from this. If the area is very big, then collect 3 from this, like this way. So hypothetically, you divide and decide on your own. In a situation where distribution of pig holdings is limited, then follow the snowball technique, where in the first household a pig farm is visited for sampling. He will be guiding the very next pig farm for the collection. Visit to the next pig holding. In that way, you have to go and collect the samples. This is the sampling plan for the entire 28 states we have given. For Punjab, the number of the districts is 25. If there are any additions, please correct me. Then number of the blocks are 43. As I told, we have taken it from the 20th census. Dr. Parvinder, correct me. She has told around 48,000, but it is showing here 52,000. Again, 702, there is a correction. 796, I think we have given it to them. Average number of the samples per district becomes 28. Biosafety and biosecurity, movement restriction. Again, Dr. Jagdish will be speaking in detail on this. Cleaning and disinfection of the infected premises and the environment. Quarantine of new animals into the herds. We are actually planning for the control and subsequently the freedom from classical swine fever should be our goal. So the program is planned for the 5 years. If we achieve the goal well before time, that is well and good. So the first, this one will be our annual vaccination. And then we have to, after 5 years, we have to stop the vaccination, then go for the surveillance and freedom from the classical swine fever. So no disease for 3 years after vaccination, that we have to go for the clinical surveillance, in the sense there should not be any clinical outbreaks of the disease. Then no disease for 2 years after vaccination is stopped. Stop the vaccination, observe for 2 years, then there should not be any clinical surveillance, virological presence, or serological presence of the disease. So this is how that takes around 2033. This is in a very exhaustive way of eradication program we have given. But before that, I think if we all together join our hands, we can control and eradicate the disease well before 2033. These are some of the outbreaks of classical swine fever, surveillance and screening we have done in Karnataka. And this is one area wherein Purdamma temple, one temple is there. They mannat mangte hain. And if their murade pure ho jate hain, then they will offer the pigs and piglets as this one to the deity. So there it is, I think that local municipality has allowed them, and there is one designated area. They bring the piglets and they sacrifice for the deity. In that way also we collected some samples and screened, and they looked this one also healthy. Yeah, this is all about nutshell about the action plan and control program we have developed, and Punjab is beautifully, it is following, and it is doing. I'm in constant touch with Dr. Gagandeep Kaur madam, and she is explaining the day-to-day activities of all the activities undertaken in Punjab. And I wish there should not be any. 1 year you have seen there are no outbreaks, and hope you will continue to maintain the CSF free status in subsequent years through vaccinations. This is all about. This is one important pilgrimage place dome in Vijayapura district of Karnataka, and this was built in 17th century by one of the Adil Shahi dynasty, and inside it's a very big dome wherein you don't see any pillars. It is a very vast and big structure, and it is very famous. This is all about the action plan. Thank you very much.
Thank you so much, sir. Sir was talking about the year-wise work plan for the successful implementation of CSF control program, and each component was explained so clearly that no doubts are left behind. Still, anybody is having any further clarification, if you need, you can kindly contact Patel sir through mail. And thank you so much, sir, for such a clear and elaborate presentation. So moving to the next presentation, today we are having with us Dr. K.P. Suresh, sir. Sir is the principal scientist at ICAR-NIVEDI. Sir is the brain behind successfully formulating the sampling plan for all the control programs implemented by DHT Government of India. And in that way, sir is an integral part or the backbone for all the ongoing disease control programs in the country. So today, sir will be talking about the sampling plan, its importance with special reference to CSF in Punjab. Sir, you may kindly share the screen and start the presentation.
Okay, thank you, madam. Thank you. Thank you, Sijo, for introducing. I am unable to get into my login because out of 100 already, it is 100 capacity, this one. So I took the seat of Dr. Patil, and I think my site is visible now, an address.
Yes, sir. Yes, sir. It is visible.
Good morning, everybody, and you know, you are experienced with the FMD. very well. FMD really went through a lot of trouble while implementing the sampling plan. Sampling plan basically required, the random, it should be random sample and it should be representative sample, so that ultimately whatever the calculation you do on sample should be valid, statistically valid, and it should be more robust and interpretable. In that line, Government of India has asked me to develop sampling plan for FMD and implement it for surveillance as well as monitoring. In the monitoring goes with the pre and post in the same sampling plan, and whereas surveillance only one time you have to do. And methodology adopted for monitoring and sampling, the surveillance, both will be little deviations are there. And the subsequent sampling plan will always be generated with the previous one, looking into the results, previous results, as well as the previous frame, wherein the villages already selected will not be selected in the next sampling plan. So while developing a sampling plan for any monitoring or a surveillance, we know that we have followed, we are asked to follow the OAE recommended sampling plan, like two-stage random sampling methodology. First stage, why two-stage is the first stage and second stage. There are two stages are there. The first stage, we are selecting the villages because we can't go one single stage sampling plan, because we once, for example, if all the animals tagging is come, results have come, tagging information is available, we can go with a single stage sampling plan. Since the we don't have that animal level information, so we are taking the village level information first. That first stage we go into the selection of villages. We'll go into the first stage. Once the village is selected, then second stage we'll select the animals within the village. That's why it is a second stage. Two-stage information is collected and it is recommended by OAE for this purpose, for the animal surveillance or monitoring of livestock diseases. So accordingly, we have adopted the two-stage for this one. We can go into the address and select the sampling plan. First, we can see FMD, then monitoring surveillance, then brucellosis is there, PPR is there, then finally the fourth one is CSF. So in our case, all the action plan is given there, and technical programs guidelines also given in this. We can download your Excel sheet, it is in Excel form. For example, Punjab, Punjab you can download. Here, select and download. I don't know, it's supposed to come. It is not come. Supposed to come. Maybe because of screen, it is a problem. Due to screen is visible now. Hello, madam, Siju?
Visible, sir.
Okay. So you can download the Punjab state, and because of this sharing mode it is there, it is not downloadable now. I don't know, some issues may be there. The Punjab, we have given a result, some of the selected villages, number of villages, and within each village, a number of samples, how many samples to be surveyed, and within village, if we go, and within Excel, we can see referred. Within that, we have given a reserved villages also. Reserved villages can be used when the particular village, any village among the selectable villages, which is not accessible or any issues are there with particular village, we can use a reserved village, not take the reserved villages for the granted initially. Complete all the villages which have given the sampling. Then if any village, specific village is not accessible, a logistic problem is there, or any other issues are there, then only you replace with the reserved villages, which is also given in the marked row. You can see the marked row, each and every district is there. You can replace. Even then, in spite of that, still some of the villages not accessible, or population is vanished, population is not there. Still, please write if any population is not at all available. Now, recently I got some query from some other state at Patna or Bihar, I think. The districts, with some districts wherein the population is missing, there is no major population. because you have taken a 20th census population as a base information, and based on that sampling plan is generated. If any issues are there, please contact me, send a mail to Patil, Dr. Patil, who is the coordinator for this program. You will do the justification for that, or any other villages we can substitute, or within the available resources. Compliance, even 80% compliance is a good compliance. If you complete 80% of the compliance rate is good enough for us for further calculation of further sampling plan. So this is what about sampling plan. There are and also I don't know, nothing more. And I think if any issues are there in the sampling plan, I think you are experienced with FMD. FMD going very wonderful, and everybody is doing very well, particularly the monitoring and surveillance. Everything is uploaded in the website. If any issues are there, please contact me or Patil. He will definitely help how to go about. The issues comes when the sampling you are doing at a village, already village level. When you select, we have guided up to village level. Per village, how many samples to be selected, also given. But once you go to the village, how to go about, how to collect a sample, particular specified sample from the village, also specified as an example one of the village, and divide yourself randomly. The once you go into the village, divide yourself the village boundaries, and accordingly the required samples will be taken. The point to be insisted here, point is here. Suppose you go to the village, there you are given only 20 samples to be collected, and you collect 25 samples are available. You collect. I don't think such things you don't do that, because 5 samples extra collected is not provide any additional information, and it is not good for even the wastage of resources. Don't do any additional information, any additional samples. Don't collect it. Even one sample less may be better, but two less sample collection is also. Please mute, please mute, somebody is talking.
Dr. Jitendra Kumar, please mute.
Please mute the your mic. See, the additional samples which you collect will not have any information, additional information for me for calculation of any herd immunity or whatever it is. Therefore, don't collect any additional information, additional sample from the village. Village is recommended for only 20 samples. Please collect only 20 samples. Don't go more than that, because it falls outside the sampling plan. So any sample outside the sampling plan. In addition, people are collecting some samples from outside the sampling plan. Some other, you go to the village is collected 20 samples. Some neighboring villages also you want to collect something additionally. That don't do that. Don't mix up with the sampling plan. Plan is defined. Each sample within the plan is having a probability values inside, built up probability values each, so that we cannot assign any other probability values to the additional information, additional sample which you collect. Therefore, don't mix the sample to the sampling within the sample plan, whatever it is there. Don't bring any additional sample and mix up with this, because we may miss the probability values. Therefore, calculation at the end may mislead the values. So this is about sampling plan. If any issues are there, please discuss and look into this. All the states are available, already uploaded. If any state is not able to open or having any issues with the sampling plan, please contact Patil, Dr. Patil. Write immediately to the Dr. Patil. He will rectify accordingly. Thank you very much, sir. Thank you very much. If any questions are there, you can just share.
So thank you so much, sir, for sparing your valuable time for demonstrating about the sampling plan and to make them understand like how important is to stick to the actual sampling plan for the effective control of CSF by 2033. Thank you so much, sir. So now today we are having with us Dr. Jagadish Iramat, sir, Senior Scientist, ICAR-NIVEDI. Sir is the biosafety officer of our institute, and sir is having a lot of experience in working with the different diseases of pig peaks including JE, PRRSP, ASF, CSF, etc. And he has investigated a lot of field outbreaks also about different diseases of pig and helped the farmers to successfully control the diseases in time. So today, sir will be talking about the overview of outbreak investigation. Sir, may I request you to share the screen and start the presentation.
Thank you, Srija, for that nice introduction. Am I audible?
Yes, sir. Yes, sir. You're audible.
Okay, okay. So my slides are visible?
Yes, sir. Visible.
Okay.
Dr. Jagdish, make
So,
it slideshow.
Yes, sir. Yes, sir. First of all, thank you so much, respected Director, sir, and Patil, sir, for giving this opportunity to talk about outbreak investigation. And the idea of outbreak investigation, especially the state of Punjab, which has not reported active disease so far, but there are a number of factors which can lead to outbreaks. And at this point of time, any such suspected outbreak need to be investigated in detail. As we are reaching towards effective control and eradication phase, it is very much necessary in order to find out what all factors might have played towards the possible outbreak. So my presentation outline is towards what is an outbreak investigation. I know most of you are very well experienced field veterinarians. You might have handled a number of CSF outbreaks since that disease is quite old, and we have been challenged many a times with severity and the spread what the disease has. And purpose of CSF outbreak investigation, and what are the steps involved in investigation, and how this outbreak investigation helps us in control and prevention of CSF. And finally, what is the significance of reporting an outbreak? So these are a few points which we'll try to discuss. And an investigation, then outbreak investigation is a very important activity in any epidemiological investigation. It has a set of procedures wherein which we'll try to identify the factors associated with the animal and the epidemiological settings or a place, and the environmental factors, and what are the mode of spread of a disease. And such information is very valuable in terms of disease control and prevention. So the entire procedure of doing this activity, we comprehend under the heading of outbreak investigation, and we'll try to see what we do as a part of this investigation. And what is the purpose of outbreak investigation? So what I see is the direct and very important significance of outbreak investigation is to identify the disease and its causative agent. That's the primary aim of any outbreak investigation. The second is, once if the disease is endemic and we know based on clinical features and other ways that a particular disease outbreak is there, then the second important purpose of doing outbreak investigation is to find out the source of infection. So both are very, very important in terms of disease control and prevention. So those are very direct purposes of outbreak investigation. So if you look at indirect purposes of outbreak investigation, so assessing the impact of vaccination. So as you know that we do surveillance in order to see the increasing, decreasing overall trend of a disease once we start with the vaccination program. So if you are able to effectively investigate an outbreak, then the impact of vaccination in terms of decreasing the number of outbreaks reported is one important measure for assessing the impact of vaccination. And also to assess the events of vaccine failure. You know that vaccine effectiveness is one important parameter which decides the success of an control program. So there are a number of parameters associated with the vaccine, starting from the host factors like age, breed, and gender, and environmental factors, cold chain. So all these, and circulating virus, match and mismatch between the vaccine strain and the field strain. So all these factors play a very, very important role and also decide the effectiveness of a vaccine. And hence, vaccine failures, and if we have to account for, a thorough investigation is most important. So these are some purposes why we do outbreak investigation, and these are to be kept in mind while we consider CSF outbreak investigation. And definitely, outbreak investigation is the one which gives us a point of intervention, which leads us to control and plan the future prevention of the disease. So for the sake of understanding, the outbreak investigation is divided into 9 different steps. But otherwise, most of these steps are done simultaneously under field scenario, just to make it understand and bring in a clarity. How do we go about doing investigation? It is divided into 9 different steps. Otherwise, it's very much, many steps are taken simultaneously once we are in field while we investigate a disease. The first step is to prepare for the investigation, and the second one is to confirm the outbreak. The third one is verify the diagnosis, and the fourth one is case definition and identification of the cases. Fifth one is to perform the descriptive epidemiology, and sixth one is data analysis. Out of 9 steps, the first 5 steps are very, very important and which are expected to be carried out by a field veterinarian.
Hello.
And can you please mute? So first 5 steps are important in terms of a field veterinarian who can very well carry out the investigation, whereas the other 4 steps are of more research oriented, which might need some level of understanding and of analytical epidemiology. So I'll highlight more on these first 5 steps, and let us see how this investigation will help us in understanding the disease in field.
ठीक है.
So outbreak reporting is very, very important, and you all know better than me, like how a veterinary doctor gets an information regarding an outbreak. Is it a farmer who comes to you, or is it a field observers who bring the information to you? So there are many ways. Many times we get information from media whenever it goes beyond certain proportion. So there are a number of ways how an outbreak is reported in addition to our official channels. And getting such information and verifying such information is very, very important before we really decide on outbreak investigation. And once you have such information, going to an outbreak investigation needs a lot of preparation, because you are going to an unknown place where you will not having a proper expected and timely help. And for that reason, we have to really prepare ourselves well so that we are complete when we reach the field scenario, which would include the data collection proformas. Usually we call them as questionnaires or proformas, which need to be prepared and kept in sufficient numbers. And the sample collection material is one more important preparation, which needs like what kind of samples we are going to collect, and what are the requirements of sample collection, and how they need to be transported, and what are all the packing materials. So these are very, very critical, because like sample collection and transportation itself is a very significant component which decides the quality of laboratory result. So if you send a sample in a bad condition, definitely whatever results we get is always questionable. So because of these reasons, really preparing yourself, considering the field scenario for all possible requirements for an sample collection is most important. Additionally, personal protective equipments are very, very important. Though we are going for a particular disease, but you don't know in the field, like there many a times there are mixed infection, many a times there are zoonotically significant diseases. At the same time, that the fomites and other means of transfer of a disease from one farm to another farm is very, very important. So considering all these factors, use and disposable of PPE appropriately is very, very important, and which is also an important component of our biosecurity measures whenever we visit the farms. So this is a part of, I'm not going very detailed about it because most of you have done so much of investigations and you're all aware of these kind of activities. And once you prepare yourself, also confirm the outbreak. There are many ways of confirming it. Scientifically or technically, one should have the basal data regarding the status of a particular disease for which we are suspecting and we are planning to go for an outbreak investigation. So many a times we may not have such kind of basal data which suggests that the current observation is higher than what is been observed previously. But we do have a general observation and impression, like at a given point of time in a given place, in a given species of animal. In this case, it is a pig, and whatever we are observing in terms of a disease, say, for example, classical swine fever, you were expecting a certain level of a disease, but here in this particular scenario, we are seeing more than the expected level of the disease. So which might be definitely due to some changes which are associated with the host, which are associated with the agent, or they might be associated with the environment at both at the macro and micro environment. So if you have to, if you have such observation and if your impression says that definitely it is an unusual situation, which need to be investigated in order to figure out what went wrong, in order to find out those kind of things, outbreak investigation becomes very, very important. Before planning to visit the suspected area, the necessary information regarding the farm and what is the current situation, what are the information they have so far from the field veterinarian or the local diagnostic laboratory. So these kind of information, as much information we collect before going to the field, so much beneficial it is in order to plan our investigation more effectively, timely, and also come out with a very good observation, which would definitely help us to control and prevent the infection. So towards that, on the right side, I'm just showing a typical graph. The line below the green dash line is what the basal level of outbreak we expect, and that is sudden spurt of outbreak increase, and that really alarms us in order to figure out something is wrong in the field, which is associated with any of the factors which might have caused this outbreak, and that is where an investigation really demands. So, once with this background, we get into the field, and once you are in the field, there are definitely different stakeholders who can give a lot of useful information in order to investigate properly and also collect necessary information. The first stakeholder is a veterinary doctor who has observed the outbreak before we reach there, or he himself might be investigating an outbreak. If he's an investigating officer, then farmer becomes the very important stakeholder for him to collect all necessary information. So visit to the farms and its surroundings is very, very important. Always keep in mind, whenever we visit for investigation, three things are most important. One is the animal, what are all the animal associated factors, and how are you recording those observations is most important. The second one is time, when outbreaks started, which is the first case, first farm, and what is the current situation? Is it one farm affected, more number of farm affected? What is the timeline of outbreaks reported? Time component is most important. And third one is the place. Place is very, very important in terms of location of the outbreak, and the surrounding spatial features are very, very important in order to identify the possible risk factor which might have caused this particular outbreak. So always keep these three things in mind and direct your investigation towards these three factors. Animal, when I say animal, which breed it is, which age it is, which particular gender it is or sex it is, and is there any specific observation when you look at the host factors. Comes to the second one, which is very, very important, is the time, and the third one is place. We'll get into those things very briefly as we proceed with this discussion. And collection of epidemiological data using questionnaire tool is very, very important. And in that case, as I already highlighted, animal, place, and time are three components which becomes an integral part of our investigation, and about which we'll be collecting necessary information in order to understand the reason for outbreak. And recording, 1 minute. So recording a detailed clinical manifestation is also very, very important. Though we traditionally study in textbook kind of clinical science, but believe me, you will not every time find same kind of clinical manifestation in the field condition. So observing the clinical manifestation, recording every simple observation, what you see right from lacrimation, conjunctivitis, hyperemia, which part of the body hyperemia is observed, is it diarrhea, omission? So collecting as much detailed information as possible, interaction with the farmer, and also our own observation if the clinically suffering animal is available in the farm is very, very important. Never take it as granted. Like classical swine fever means we have a set of clinical signs which we have traditionally come across, but definitely diseases are changing with the time. So hence recording these clinical observations is very, very important. And noting down this, and next point is if you have an opportunity to perform a PM, is really post-mortem investigation is one more important component which will be dealt by my colleague Dr. Shiva. So there also it is very, very important. Don't again succumb to what we know. Be open-minded and try to observe what all you can, considering as if you are seeing the first classical swine fever outbreak in the field, so that will not miss any such observations which might be due to change in the virus, change in the host susceptibility, change in the environment. So recording these observations, especially by a person who is visiting first time, is very, very important. Collection of clinical samples, already Patil sir has pointed out like what all samples to be collected, and especially in outbreak phase, collecting a right clinical sample, which is also highlighted by the madam, the appropriate samples like spleen and tonsil, which are most appropriate samples. Additionally, you can collect other tissue samples. And collection is not only important, but packaging and making sure by the time it reaches to the laboratory, the sample is as good as it is. So next is once you collect the clinical samples, and you know that there are different levels of diagnosis, what we usually do. One is clinical diagnosis based on the clinical symptoms, what we observe in the field condition, which is routinely done by veterinary doctors. And followed by if you have some PM changes, which will again enforce our clinical observation so that we are more closer to our specific diagnosis. But these two observation alone is not sufficient. As earlier speaker has pointed out, there are overlapping clinical signs across many diseases. So laboratory confirmation is most important, which is a confirmatory diagnosis for us. So that's where we have collected the sample and sent to the lab, and proper test has to be done in order to ensure and do the diagnosis specifically. So once that is done, then now we know in the process of outbreak investigation. So based on the clinical science, it has certain information to be accounted. Say, for example, already pointed out, I'll not spend much time, high fever, weakness, anorexia, conjunctivitis, diarrhea, cyanosis, skin hemorrhages. These are all, the signs which we observe. And PM lesions, again, I'll not spend much time because there is a dedicated talk on that. And these are few observations which are already highlighted. And considering these two observation, differential diagnosis and mentioning what it is suspected for is most important. So then comes your laboratory confirmation, which is done by different tests like serological or molecular test, which is now the disease is confirmed. In this case, maybe it is confirmed as CSF. Once it is done, then it is a step at which we know what it is, and in terms of specificity. And because we know that it's a classical swine fever, after laboratory confirmation, now we have a specific measure to be placed in order to prevent further spread and also to control the ongoing outbreak. And if you look into the steps, what I have said so far, clinical observation followed by tentative diagnosis. The tentative diagnosis will lead to some line of treatment, which are mainly based on the clinical signs. So at the same time, we are also sending the samples to laboratory confirmation. Once your diagnosis is verified, then you have a specific measures of control and prevention of a disease. And as early you bring these control and preventive measures, so early you can minimize the impact of an outbreak, and so early the peak can be brought down. And that is what is the urgency and in the focus of any investigator. So once we do this, then comes the next step. We know that this particular outbreak is due to classical swine fever. And the next important step is to understand the magnitude of the outbreak. See, any such confirmation will not be covering entire population of an area. Many a times a particular farmer comes to us and says that he has such problem. We go to that farm, we investigate, and we collect the sample, send it to the laboratory. We got the confirmation of classical swine fever, but it doesn't mean that it's the only form which might have affected at that point of time. As an investigation officer, it is more important in order to get into the field and identify, is it the only form which has affected, or there are a number of forms which have also been affected, but which are not brought to the notice of a veterinary doctor or investigating officer. So there comes the role of case definition and case identification, which is a terminology used in terms of detecting all those forms and animals which are undergoing such infection, but not brought to the notice of an investigating officer. So we need to have a tool in order to identify such forms for which the case definition and identification of case, which is an important step. What we do in case definition and finding a case definition is really a standard set of criteria for a disease, whether the animal or a farm should be classified as a healthy condition, or it is unhealthy condition, or a diseased condition. And there is a need of case definition because once you go to any farmer other than who has reported to you, so you have to interact with him. If you have to interact with him, how will you ask him, like, is your population is affected with the CSF? So that kind of questions may not be very easy for a farmer to understand. In turn, we'll ask based on the clinical science. So incorporating a clinical science and formulating a case definition is very, very important. And as early we do that, so early we know the magnitude of infection, and so early we can bring in preventive and control measures. So this is usually the channel what we follow. Disease reporting by an isolated farmer and disease diagnosis based on the clinical sign PM lesions. There is a treatment and cure. But when the disease reporting by more number of farmers, which is a kind of epidemiological event, disease diagnosis and based, again, we are doing it initially by clinical signs and PM lesions and followed by treatment. But if a huge number of farms are affected, treatment becomes very, very challenging in order to cover timely. So that's where we call it as an outbreak situation, and for which your basal disease data is very important. And once a confirmatory diagnosis is done, as I pointed out earlier, verifying diagnosis and reviewing the clinical lab findings and bringing in a control and preventive measures is very, very important. So there comes the final step, which I was saying, defining a case and identification of a case, which is very, very important. So usually the case definition will involve the species affected and the place which has reported this particular outbreak and the time of the disease and the clinical signs. Incorporating the information related to these 4 components, we formulate a case definition. Say, for example, in this particular case where we'll see that a particular age group of the animal is affected, or particular sex of the animal is affected, or breed is affected. And in case of place, say, for example, a particular village in a district, say, for example, in this Alampur is one such village in Punjab where you have reported this particular outbreak. So we should restrict our geographical location where we are investigating. So unless you define your place, your investigation is not complete. So clinical features, definitely, as I pointed out, when we go to a farmer, we'll ask him, see whether your animals are having high temperature, whether they are showing off feed, anorexia, do you see any bluish color of the skin, So this is how we find out the new cases or new farms affected. And then we'll get an idea. In case of Alampur, it's not the only farm who reported us, but there are 10 farms which have been affected, but not brought to the notice of to the investigating officer or veterinary doctor. But when we went and proactively surveyed and found out, so these are the farms which are affected. So then your case definition, including all this information, becomes Akshar pigs from Alampur pig farms under the age of 1 year with a high temperature, anorexia, lethargy, cyanosis of skin, enlarged lymph node observed between 1st June to 31st August 2022 is your case definition, which means all those forms which are satisfying this definition are the affected forms which need to be considered for further investigation. So this is what is very, very important with respect to identifying the cases. Many outbreaks, the cases that prompt the concern are often small and unrepresentative fraction of the total number of cases. That's the reason why we do case identification. So again, reiterating the same concept with the pictograph here, if the red ones are the case reported, which are actually reported, and veterinary doctor went there and collected the sample and confirmed it as CSF. But there are definitely the brown colored blocks which are also suffering, but they were not brought to the notice of veterinary doctor. But such things are captured through case identification, for which you need to have a case definition, which I highlighted. So that is most important. Once you have these information, then it comes to performing a descriptive epidemiology. As I pointed out, 3 components are most important: animal, place, and the time. If it comes to animals, the species, age, sex, and breed are most important. When it comes to place, there are certain geographical features which need to be considered. And time component, I'll come to it, where we have one analysis which we call as ICAR, which helps us to identify likely period of exposure, and that is most important in order to find out your risk factor. Let us see the time component. And in general, the outbreak data, when it is plotted at a different time interval, it provides a different level of information. For today's discussion, we'll restrict ourselves to the third graph on your right-hand bottom, which is the number of cases against date of onset, which is, important. This particular assay, where we are using time component of the data or the outbreak, which we call as epidemiological curve, wherein which on your y-axis we have number of cases, on x-axis we have number of affected cases, time period. And so this is how, this is a simple graph, but the data you need to collect in the field is the date of onset of illness. Say, for example, you are going to a farm A and you are interacting with the farmer. The first question to be asked is, when is that the first case of this particular outbreak is observed? So today is 5. If he says, I observed it like 1 week back. So you have to note down exact date when he has observed the first case. Following that, you have to ask day-wise, what is the number of cases he kept on observing. Today it is 1 case, tomorrow it is 3 cases, day after tomorrow it is 4 cases. So day-wise, number of cases reported has to be recorded. That is the data which you are collecting in the field. Once you collect that data, bring it and plot a graph wherein which your y-axis is number of cases and x-axis is the date of onset of a illness. So that gives us a graph which has a lot of information in terms of identifying the distribution of the cases over time. If there are, what is the outbreak magnitude and outbreak pattern of the spread, and what is the likely time period of exposure. So these are the kind of information we can extract from that particular graph. If it is the only single source of infection, this is how your plotted graph looks like, wherein which the period of exposure is very brief, and you usually observe all the cases fall into 1 incubation period, and typically there is a sharp rise and gradual down of the slope, what you are seeing it here. Similarly, depend upon the situation and the nature of the disease and source of the infection, you will see different graphs. This is one more pattern which you may observe, wherein which there is a long period of exposure and there is a gradual increase and there is a gradual decrease in the number of cases. And similarly, if it is an intermittent infection, this is how you see the graph, and mostly they are irregular in nature in terms of peaks observed. And there is one more pattern of graph which you might observe when that data is collected for a long period of time. And this is how we call it as an propagated outbreak. But most of the time, CSF being a very acute in nature, we tend to see this particular pattern, which is a point source infection. And probably you will be paying more attention towards that graph. And these are other graphs are more of a extended period, and the nature of the disease is also important while we do that. And as I said, these kind of data helps us to identify the likely time of exposure. So when you plot this graph, like number of cases against the date on which they are reported, then you will have to do an exercise on that part, like identify the peak of an outbreak. Say, for example, in this particular example, the date of onset is 9th, it is observed. There is a 10th date, 11th, 12th, and 13th. On the 10th, there is a maximum number of cases which are reported. And in order to find out the likely time of exposure, so just to brief you, the likely time of exposure is the time during which we assume that this particular set of animals got exposed to the source of infection. So that period is very, very important. And as much we narrow down that period, so much specific we will be in our investigation in order to find out the source of infection. So towards that, this particular graph, it helps. And for this to be performed, you have to know specifically the incubation period of the disease. And you know that all the diseases have incubation period defined, and they are usually in the range. There is a shortest incubation period and there is a longest incubation period. There is also an average incubation period. So these three parameters one should know about this particular disease. For classical swine fever, we see 2 days is as minimum as a incubation period. 7 days is an average incubation period, and around 14 days is an longest incubation period, which is observed under field condition. So these observations we have to keep. As I said in the third graph, as you find out the peak of a outbreak, so from there you have to come back the average incubation period and identify the date. Then comes to your the first the date on which number of cases reported. From that date, you have to come back with the minimum incubation period. As I said, for CSF, it is 2 days. And if you come 2 days back from 9th, 7th is the incubation, shortest incubation period. The animals which have exposed on the 7th with the shortest incubation period, they have exhibited a clinical sign on the 9th. Similarly, the average incubation period in a population, there is all maximum number of animals will respond in a average incubation period. If you consider 7 days as an incubation, average incubation period, then you have to 7 days go back. And that is a point when we think majority of the population exposed. And that's how we saw the number of cases emerging on that day, maximum number of cases emerging on that day. The last case, what we are observing this outbreak, which is shown as 13 on your y-axis, that is a case which has undergone a maximum incubation period, which is 14 days, which we are highlighting. So from 13th, you have to go back to 14 days, and which is falling on the 3rd of that particular month. So now the likely period of exposure is between 3rd and the 7th. So this is a period where you have to really focus and interact with the farmer as well as associated stakeholders in order to find out what changes have happened in this period, which might have contributed for the disease outbreak. So identifying this window period is most important. Otherwise, we are just going without any proper direction in terms of our investigation, which is very, very difficult to figure out what is the source of infection. But if you are able to define the period between which there is a possible exposure of a pigs or the population to a source of infection, then it is easy in order to ask for what all activities happened in that particular period, and that will help us to find out the possible risk factor which might have led to the. So this is what it is highlighted. Most likely period of exposure is what I have shown here. And with this, how the time component of a outbreak investigation data is useful in solving the outbreak and also identifying the risk factor is what is highlighted here. Coming to one such example, which I'm just highlighting to show you. As I already said, this is the left-hand first table is the one, the data you are collecting, onset data and the number of cases you have identified. Then you are arranging it in an increasing or decreasing order, and then putting that into a graph. And this is one particular investigation we have done some time back. And I have shown here the minimum incubation period, average incubation period, and maximum incubation period. So here, this is a period, if you consider 19th June and the 14th June. So this 5 days window period is when the animals got exposed to the source of infection. And now all your questions should be targeted for this period in order to identify the possible source of infection. This is a very handy tool. Only requirement is day-wise cases. Day-wise cases, if you are able to collect best possible way with interaction with the farmer, this happens only when we reach the outbreak site as early as possible. It is all with the remembrance. We still don't have documentation at the farm level. Whatever he remembers, he has to tell us. And since it is a population approach, probably it is very difficult for him to give the discrete number. But as early we reach there, probably we have some valuable data coming out of these kind of time component. And that is very useful information. And similarly, as I was pointing out, just for the sake of understanding, if you see any disease, it has an exposure period. Following exposure period, there is an incubation period. Following incubation period, there is a prodromal stage during which the infection is picking up. Then there is a height of infection where a clinical exhibition of the disease is observed. Then we have a convalescent phase where animal is recovering. So this particular exposure period is what we are trying to identify through this particular data. So that for that incubation period is one which helps us a lot. So this is a very, very important tool one should employ in order to understand this one. As I said, if you come to animal, it is mainly 4 important parameters: species, age, sex, and breed. In this case, species or pig, either wild pig or a domestic pig is the only difference. Otherwise, we have pig as a species. Age, sex, and breed are the host factors. Coming to the place is one important parameter, descriptive parameter, which we need to get into. Here, many a times, taking a help of farmers in order to map the outbreak setting is very, very important. We call it as a participatory approach, wherein which once you take the farmer's help, you locate the outbreak point. Once you locate the outbreak point, with the help of a localite as well as a farmer, you try to locate other possible risk factors in that particular village or a place. Say, for example, location of the other farms which are nearby, and what is their situation, whether they are affected, because farmers will have more valuable information, internal information, many a times, which may not be available with the doctor at the point of investigation. So that way, collecting and mapping other farms nearby in your map is more important. Even a pencil and simple white paper will help us to come out with the map. And major water bodies, roads, which are connecting roads, whether these roads are used for transportation of the animals, or any slaughterhouses are located nearby, retail pork shops are located nearby, veterinary hospitals, breeders, and farmer shops, any forest areas, especially if you are accounting for a wild boar or a wild pig, locating the forest area, asking a question like how frequently you sight wild boars, is it whether your farms have been in contact with the wild pigs. So these kind of information and plotting them into a map is really important and useful in order to come out with a possible source of infection and direction of spread. So this is how we do it. Your GPS is one tool, very, very important tool. Nowadays, every smartphone has a GPS. So locating and capturing your latitude, longitude is very easy. Once you do that, put it into your map, and so you can see the location of the map, how the roads are traveling, where is the human habitation, what are the water bodies. So these kind of informations are very much visible as early as you put those points. And you have to account for husbandry practices, elevations, and things like that. And with those information, definitely our investigation will lead towards identifying the possible risk factors. And again, I'm bringing in the same steps of outbreak investigation where we have done the control and prevention measures. And at this point of time, we know like what is the period of exposure, and with interaction, we'll know the possible risk factor. And also with the information of the place, we'll know like the location of the location or the path of transmission of an infection. With this much of information, we are now ready to recommend what are the control and preventive measures to be taken at that point of time. So your investigation can continue with a more sophisticated approach in order to establish the association or causal factors associated with this particular outbreak. But at this point of time, this much information is really valuable. And this information is also valuable in terms of formulating your biosecurity practices more specifically. See, when you have a data to say that your swill is what, or your waste or the what which have been accounted for the infection, then definitely your biosecurity measures will happen accordingly. So we have many follow-up presentation where people will talk about biosecurity. In the interest of time, I'll just rush through these slides. And these are few disinfection measures, you know it. And in summary, I can only say that outbreak investigation is a very important epidemiological activity, which will help us to identify the source of infection. It facilitates to identify the cause of an outbreak, provides a basis for analytical studies, helps in immediate intervention to control and prevention. So with this, I'll just stop here. And if there are any questions, please lead us to Dr. S.S. Patil. We'll be happy to answer. And if you have any such outbreaks where you need the services of NIVEDI, we'll be happy to extend. A team of scientists can visit and do the investigation. With this, I'll thank you all for your patient hearing. Thank you so much.
Thank you so much, sir. Sir was talking about the different steps that need to be followed systematically for outbreak investigation in the field. Thank you so much, sir, for the clear and elaborative presentation so that they could be able to understand each component that you described. Thank you so much, sir.
Thank you, sir.
Yeah, thank you, sir. So now we are having with us Dr. Shivasharanappa, sir. Sir is the Senior Scientist, ICAR-NIVEDI. Sir is specialized in veterinary pathology with a lot of experience in conducting postmortem examination in the field. And he helped so many farmers in timely controlling the disease outbreaks. And today, sir will be talking about the postmortem examination with respect to classical swine fever. So may I request Dr. Shivasharanappa, sir, to share the screen and start the presentation.
Thank you, madam. Screen is visible?
Sir, screen is visible. The slideshow you make it.
Yes. Yeah. Thank you, Mr. Director, sir, and coordinator of CSF-CP, Dr. Patil, sir, and other esteemed participants. So already. Can you please mute microphone? Yeah. This topic actually I'm covering on postmortem examination of CSF suspected pigs. Earlier, the postmortem examination of suspected CSF pigs was relatively, it was a one-way direction, because earlier in our country, the ASF, African swine fever, was not there. So now it is a very big challenge to examine the both ASF and CSF suspected pig carcasses so as to identify very striking lesions causing with either CSF or ASF. So both are really confusing, and it's a very thorough examination is required during postmortem examination. As you know, the purpose of postmortem examination is to examine self, to identify the it's basically wisdom from dead to living. and to identify cause of death or to confirm diagnosis, or simply to satisfy our curiosity why animals are dying like that. So as you know, the requirement, basic requirement like site and different reports and sample collection needs to be prepared and all. Actually, there are two things we should be very points to keep in your mind. One is the conducting postmortem examination of piglets. It's very relatively easy if you follow the simple steps like this. And whereas in adult pig carcasses, it is like it requires some skill, and as this in piglets, we can do the dorsal recumbency and the cut open the carcass from the ventral surface of mandible in V shape, so that the neatly we can see the viscera, and without any contamination we can collect the samples. Because this is a viral, we are suspecting virological disease like CSF or ASF. So the clean cut and the thorough opening of the carcass without the making the contamination is very, very important. So this is relatively easy in piglets to open in dorsal recumbency, but it is very difficult in adult pigs like weighing 150 kg, where we can follow the lateral recumbency method, where all the four limbs can be slit through their base, and we can cut from the cervical regions to the abdomen, so that all the viscera can be seen and properly documented, so that because the first visible change is very, very important to note down, like liver, kidneys, intestine and lungs and all. So the opening the adult carcass, pig carcass, requires a very careful methodology. So as you know, coming to the classical swine fever, there are, as we all aware that there are 9 to 10 very classical, very characteristic pathological lesions in CSF, as we understood. But now it is very, very challenging because of the African swine fever, where most of the lesions, most of these mentioned gross lesions are also present in the African swine fever. Like when we open the carcass, there's a multiple pinpoint hemorrhages all over the skin, ear, then even proximity of the legs, then subcutaneous hemorrhages, superficial lymph nodes. So where we need to focus here is the pigs died due to maybe swine fever, African swine fever, or classical swine fever. We need to look very carefully to all the lymph nodes. We should know that where are the locations of lymph nodes, like they are mesenteric, hepatic, renal, and ileocecal lymph nodes. All show the very, very clear picture of the classical swine fever as well as African swine fever. So we should not miss to look into those lesions in the lymph nodes. And also spleen is also one of the important indicator, as we are aware that there is a splenic infarct, splenomegaly and all. Then also the heart, epicardial surface, we get hemorrhages, then liver also changes, and lungs also show bronchopneumonic changes. And of course, kidneys, there's a typical pinpoint or petechia, and many. Like in chronic cases, we get button ulcers, as you madam explained earlier. These are the few skin lesions. So important the finding what we are observing, because since 2-3 months we are conducting regularly even African swine fever suspected piglets and pigs, and also the 2 days before we were in Kerala to investigate African swine fever outbreak investigation. We did few postmortems there. So we need to understand like both the diseases, like because I'm comparing here African swine fever, because it's very difficult to differentiate both the lesions based on the clinical presentation. Both the diseases having acute, subacute, chronic, and other forms of disease. The one striking feature in both the disease, like the palatine tonsillar necrosis, different forms, like maybe in acute, and more darker, it shows the more chronicity of the infection. So try to identify this area, the mandibular area, where we can see the thumb, as madam was mentioning, thumb sized 2 palatine tonsils. This is very characteristic feature in the classical swine fever as well as the African swine fever. Other things like liver lungs, and they show very because these two diseases are vasculotrophic, like they generalizely they cause the vascular coagulopathy, they cause vascular endothelial damage. So many organs we get hemorrhages and sort of things. So here in this picture which I was showing by arrow, the very typical hemorrhagic or mottled appearance of mesenteric lymph nodes when we compare with the normal lymph nodes. So we should not miss such type of lesions which show us the direction to suspect the classical swine fever. As see this like splenic infarcts and lymph node like hemorrhagic lymph nodes and all. So now the baseline now the disease may not show the exactly the classical type of lesions. Different based on the clinical presentation of the disease. Maybe it is early form or late form or subacute form and all. So sometimes we may get characteristic this type of splenic infarcts, the rounding heads and all. So whatever 2 days before we have done as many as 7-8 postmortem, we didn't get any classical type of splenic infarcts or something like that. So the disease pattern is changing. We may not get clear picture of the classical signs like classical lesions like petechial turkey egg appearance of the kidney in the classical swine fever, and also in few cases in ASF also we got similar type of lesions, even the pericardial hemorrhages and all. So there are few studies from India which shows the characteristic lesions here. We can very well appreciate here the chronic cases in button ulcers in intestine and gastric mucosa and many other changes. This is also the chronic form where the typical necrotizing button ulcers, even tonsillar necrosis, severe hemorrhagic lymph nodes like this type. So remember these similar findings we are observing in except these button ulcers in African swine fever cases also. So all the lesions documentation is very, very important. I'll show you final slide where what are the important things we should remember to differentiate both the diseases. So this is all the classical swine fever, chronic cases of classical swine fever, button ulcers. And most important in chronic form of CSF is we get reproductive problems, like because it is the placental route, it gets transferred into the fetal early embryonic death, fetal maceration and mummification. These were very characteristic lesions in the classical swine fever in case of chronic cases. So persistent cases and all. So coming to the major histological changes, again here many changes are similar in both the classical and African swine fever. Like most important is the splenic follicles, lymphoid follicles get depletion and necrosis type. So this type of very characteristic finding we get in spleen. And here also the divide of the lymphoid cells, spleen like very sparse population, very few cells, lymphoid cells we get in this CSF cases. Even if you see the intestine, the pair patches and all, we get very few cells in lymphoid follicles and necrosis also. This type of lesions we can suspect this, yeah, these are due to classical swine fever and all. So as you know, the kidney gross lead shows infarcts and also histopathologically there is a typical corticomedullary junction area, we get diffuse hemorrhages. So this is also very characteristic finding in CSF. And of course, this is a viral fever and in liver and all, whatever the pinpoint hemorrhages and all, it is there. And also the infiltration of mononuclear cells in the periportal area and all. Most important thing, if you practice collecting the tonsil, the palatine tonsil, we get this type of necrotic, coagulative necrotic changes. So this is very characteristic in classical swine fever as well as now in African swine fever. So this we got recently from the African swine fever. So the similar changes we can very well appreciate in the palatine tonsil. This is a histopathology of tonsillar area. Like you can very well see here, the cells are necrotized and very few cells. Otherwise, in normal tonsil, we get good number of cells. Very thick population we get here the lymphoid cells here. So this is all natural cases we can very well evident here. And of course, bronchopneumonia and intestinal changes also it is there. So these last two slides, I will focus on the African swine fever studies, which are published already. When we see the, of course, in the classical swine fever also, we get the diarrhea and blood mixed diarrhea also. In even African swine fever cases, also the similar findings like perianal region, the blood clotted diarrhea we can very well appreciate. The most important difference in the classical and the African swine fever is, in classical swine fever, we won't get this ascites, that is peritoneal accumulation of fluid, or even pericardial pericardial fluid accumulation, or even pleural cavity fluid accumulation. This is only found in African swine fever, latest one recently. Whereas this is absent in classical swine fever. This is one because consistently we were doing the postmortems, and it was consistently finding in African swine fever cases, not in classical swine fever. Even it was reported by many studies there. This is also one more study for African swine fever, where the similar changes you can see, but in contrast to the classical swine fever, what we are talking now, here in African swine fever, we get more like blood clots type lymph nodes. Completely lymph nodes are more hemorrhagic, or more, it looks like similarly blood clots are placed in the lymph nodes like that. So these are very important findings in now African swine fever cases. So I have put one last slide here. You can closely examine this, like what is the striking similarities and the differences between classical swine fever and African swine fever, because very based on gross lesions, it's very difficult to differentiate both the diseases, as many states now, Kerala, Karnataka, Goa, and many cases we are investigating African swine fever cases. So the postmortem is really challenging to get exact the type of lesions what we are getting. It, as you know, the classical swine fever is RNA virus, and ASF is DNA virus. And there are similarities, like both comes from the swill feeding, like feeding of the infected material, chicken waste, and even pig waste, pig carcass waste, and all the feed. So both the factors responsible for both the diseases, and both the diseases cause generalized lymphadenopathy and vascular changes, because both are vasculotrophic viruses. And the difference is more in case of lymph node changes. Very, like as I mentioned, there is a dark blood clots, like especially renal, hepatic, and mesenteric lymph nodes. Typically, they do like blood clots. And as I mentioned, ascites, pleural fluid, pericardial fluid only present in African swine fever cases, not in classical swine fever. And here you can see the button ulcers are not present in the African swine fever, whereas the characteristic in chronic case of classical swine fever. As you know, the reproductive problems, like because of transplacental threat, classical swine fever in chronic cases cause embryonic death and fetal mummification, and I already mentioned. One more important, what based on the studies and based on our observation, what we found out is, because of vascular changes in the brain in classical swine fever, sometimes neurological form of classical swine fever also we get, like incoordination, staggering gait we see in classical swine fever. That form is absent in the emerging African swine fever cases. So, and also one more, if you closely look at the gallbladder and urinary bladder hemorrhages, which is absent in the classical swine fever, but we are getting consistently in the African swine fever cases. So these minor differences we should be able to notice every time, because it comes with the continuous postmortem examination and careful observation of each and every organ. And nevertheless, because of changing the pathogen host interaction factors or many other factors, both the pathogenesis of classical and as ASF look similar based on clinical form. So it's very difficult to differentiate finally. But only thing is laboratory confirmation is a must. So this is RNA virus can be detected, and here can DNA virus very well can be detected through laboratory confirmation. But we should keep in mind that there are few very important lesions we should focus, and so that we can come to differentiation in both the disease. So finally, also keep it in mind, even a negative finding is also finding, because when you look at the post-mortem of animal during post-mortem, whatever lesions we are having in our mind, if they are not there, so it is a negative only. So we should be open-mindedly approach the post-mortem examination of pigs suspected for classical swine fever. So we also clearly mention that yes, these lesions are absent like this. So with this, I thank for your patient hearing. Thank you.
Thank you so much, sir. Sir was precisely talking about the characteristic lesions of CSF and the important aspects that you should remember in the field when you are facing in a perplexing situation like whether the disease is ASF or CSF. Especially the last slide, sir was clearly explaining about how to differentially diagnose the CSF. Thank you so much, sir, for sparing your valuable time and for explaining everything so nicely. Thank you, sir. So moving to the next presentation, we are having with us Dr. Narayanan, sir. Sir is specialized in extension with a lot of experience in social network analysis. So today, sir will be talking about capturing a response to CSF outbreaks, capturing social networks on peak movements, vaccination, and trade. May I request Dr. Narayanan, sir, to kindly share the screen and start the presentation.
Not visible, Dr. Narayanan.
Yeah.
Please share.
Yeah. But is it visible?
Unshare and again you share it. No, not visible.
And only that folder is visible.
Yeah, now, yeah. Keep it in the slide mode.
Is it okay, sir?
Yes, yes, now. Yeah, please proceed.
Good afternoon to all, and I thank Dr. Patil sir and Director sir for giving opportunity to talk about the topic important and important program, National Disease Control Program, CSF. We are actually going to discuss about the things from informatics and socioeconomic division. Yeah, the interest is that to evaluate existing biosafety practices, social network on market big movements, and what is the extent of vaccination coverage happening in the time of control program. So, with respect to biosecurity management, evaluating the existing management practices is very important because it is very key factor in disease prevention and increasing the animal production. So, giving a current situation about biosecurity management practices adopted by the farmers will help the programmer to strategize the program effectively. And second aspect, we are also wanted to know the existing social network analysis on the pig movement and trade and sale marketing practices, because these analysis will help us to have predict the models for effective strategies and strategies for intervention and control. And also through this social network analysis, the information collected from the field level will help us to identify those factors influencing farmers adopting of disease control practices, and why they are not adopting, and what may be the reason for not adopting, what are the critical factors which plays a role for disease transmission in that particular area. That also we can come to know. And the last interest is to evaluate the extent of vaccination coverage. This is a field level survey method will be conducted at the time of end of the vaccination. because the timely and accurate measurement of vaccination coverage is required to evaluate the success of the program. It will also help us to identify susceptible groups in that locality so that there will be increasing efficiency of the. So in this process, we will be giving the questionnaire schedule, interview schedule, where we in that general profile of the farmers will be corrected from like age, education, their category, and figured size. It consists of a type of animal, a type of dairying houses they possess, and other biosecurity management practices with respect to feeding, type of feeding, or system of feeding, what they follow, and whether they follow the boiling of pig feed, or how many times they feed in a day or in a week. What is the source of water provided? Whether the water is tested or not. Under the healthcare practices, the interview schedule consists of these many questions. It talks about the vaccination, whether the vaccination is done against the contagious disease, and specifically which disease they have done yes or no type, and deworming of pigs using antiparasitic drugs, whether done or not. So these are the things we will be collecting. Then disinfection related practices, what they do at field level, that also will be collected through these tables. And regarding visitors and transportation, the information also is collected in terms of yes/no questionnaire. And marketing practices. So whether what is they going to sell for the sell to the markets, and what is the average weight of the marketed pigs. Where do you slaughter, the slaughter houses distances, all these things will be captured through this questionnaire. And specifically, if we speak about biosecurity, we can divide internal biosecurity, external biosecurity. Our interest is that what is the distance of the farm site from the main traffic routes. In time, we will be capturing in terms of kilometers. So pig farms to residential area or like other livestock farms or and slaughterhouses or all these things will be captured. Then with respect to internal biosecurity, main categories of internal biosecurity are cleaning and disinfection related questions, feeding and drinking water related questions, pig herd management, infrastructure allocation, including the immunization records, whether vaccination register they are maintaining or they are built or not built. Other questions are yes/no type. So these are things we will be collecting. Apart from that, through social network analysis, we want to identify the pathways on knowledge gained on classical swine fever outbreak and management. So whenever the disease outbreak happens, the communication becomes more important to avoid the distress sale. So here our interest is to identify the pathways on knowledge gained on CSF symptoms, outbreak, and treatment by the pig farmers through different agents and through different communication medias. With that, we come to know disease communication channels, and accordingly, the vaccination strategies and disease preventive strategies can be placed. So finally, our interest is to know the extent of vaccination coverage. So vaccination effectiveness in terms of coverage aspects we want to study. The field level survey will be conducted. The purpose is that to determine whether an area has a minimum coverage level by using lot quality assurance sampling method. The second major purpose is determining the level of coverage, and the sample will be stratified as a random sample will be selected from a lot. A simple random sample is done to determine whether each lot passes or fails in terms of meeting the pre-selected level of coverage. This is the kind of feedback test and very key to the control program. So apart from doing these things, biosecurity, social network analysis, vaccination, we want to know at the farmer level what is the constraint that felt at personal level and application of management practices concerned. In the degree of most concern, the least concern, and not at all concerned. This will give a fair idea about what is going on with respect to trigger management and with respect to vaccination process. Thank you for all.
Well, thank you so much, sir, for the crisp and informative presentation on the social network analysis of CSF, which is very informative. So thank you so much, sir. So today's last presentation is on assessment of economic loss due to classical swine fever, which will be presented by Dr. Sadish Gowda, scientist, ICAR-NIVEDI. And he's having a lot of experience in economic loss analysis of different livestock diseases. May I request Dr. Sadish Gowda to share the presentation and start the talk.
Sir, visible, sir?
Only for.
Unshare and share again. No, not at Satish. Close this and again open. Yeah, now open. Open model. Okay. Yes. Yes, slideshow. Make it slideshow. Now visible, make it slideshow, Satish.
So now it is visible. Sir?
Yeah, visible. The slideshow. Make it slideshow. Yeah. Go ahead. Please go ahead.
Respected Director Sir and Nodal Officer CSFCP from ICAR-NIVEDI. So and my dear fellow colleagues from the Punjab State. So I welcome you all for my presentation on assessment of economic loss due to classical swine fever. So as all you know that classical swine fever is one of the important viral contagious disease and economically important disease which causes significant economic loss to farmers in terms of different parameters. So in order to assess economic loss to the farmers, so we are doing economic loss assessment at the farm level or animal level and household level. So in order to assess these different economic loss parameters, so in order to we have to capture different indicators like incidence percentage, case fatality rate, mortality losses, loss due to reduction in body weight, distress sale cost, treatment cost, extra labor cost, cost of reproductive losses, and also risk factors associated with the disease occurrence. So in order to achieve this objective, so we have to follow a specific sampling procedure. So in this type of studies, we used to adopt multi-stage random sampling. So for example, for Punjab state, we used to classify districts into three risk groups: high, medium, and low. So based on number of outbreaks and peak population, we used to classify these risk groups. From these three risk group, we'll select one district from each group. Say for example, from high risk group, we'll select one district, and medium from one district from medium risk group, and low risk group one district. So in this district, each district will will select 3 to 4 blocks from each district. From each block, we'll select 1 to 2 veterinary hospitals, and from each veterinary dispensary, we'll select 5 to 10 villages. And from each village, we go to select the individual farmers or household for our dedicated farm field survey. So, for in order to achieve, in order to capture these economic losses at the farm level or animal or household level, so we'll directly interact with the farmers, pig farmers, with the structured questionnaire and face-to-face interaction between the farmers and the interviewer. So in order to get the information from the farmers, so we prepared one dedicated questionnaire for interaction and survey. So I will explain one by one each items in the questionnaire. So to achieve different loss parameters like mortality losses, distress sale losses, treatment cost, and reproductive losses, and different. So all these parameters will be captured by asking the question to farmers, and we get the information from the farmers in his farm itself. So first, in any survey, social science surveys, so we used to get the preliminary information on households, on his education level, occupation, annual income, family size, and related information, basic information, to know his socio-economic status of his farm. So after that, so in order to confirm with the signs and symptoms, so we used to take some photographs depicting different symptoms. Say for example, eye fever, discoloration of skin, hemorrhages, weakness, bloody diarrhea, abortion, these things. This is a type of secondary information to him. Apart from this, we used to go for lab confirmation. So in order to validate our primary data with the farmers. So with these two methods, we can validate our primary data to the validating our primary data to the lab confirmation. So in order to go with his disease level status and awareness of the disease, so we'll ask some different questions like awareness and any previous experience with the CSF or lab confirmation with the CSF, and also seasonality of the disease. In terms of seasonality, we used to ask questions, so which month or the season usually it occurs, and also we'll take the information from the farmers. So in order to know his output, so we'll take pig holdings in his farm, so mortality levels and distress sales, by asking different questions from number of animals to breed name, and affected animals and died animals, and also sold with CSF disease, and also distress sales in terms of number and value. So we'll also capture some information on body weight losses and also market value before CSF and after CSF. So treatment cost also will get from farmers. Say for example, veteran fee, expenses on drugs, indigenous treatment cost, and transportation cost for visiting hospitals, and also purchasing these drugs. So this include treatment cost incurred by the farmers for treating the animals, and also saving these animals. So vaccination details also will take from farmers regarding awareness, availability, and time of vaccines, and also number of times vaccinated in past 4 years, So how much, say for example, in government supply, there is no payment. So if he is purchasing from the private market, any market, so we used to capture payment for purchase, and also immunogenicity of the vaccine also will get the information from the farmers. So, and also is there any reproductive losses in terms of options? So before CSF and after the CSF, so in order to capture reproductive losses due to CSF. So labor use pattern, say for example, so in intensive farms, usually they keep some dedicated hired labor, and also hired labor some permanent nature in or some season based, or occasionally they can hired laborers for taking care of these animals. So, and also regarding vaccination, so is awareness on vaccination, and also opinion regarding the any side reaction or any some misconceptions with the vaccine. So we used to get the information from the farmer. So to conclude, what is his opinion on vaccination. So, and also we'll capture some risk parameters associated with the classical swine fever virus. So we used to do this economic loss assessment. Usually we plan for 3 times for this CSF control program period. Say for example, we used to do first baseline survey, and we first before the vaccination. So what is the status of this disease in the farm field? So, and also what is the losses to the farmer by this disease? And after 2.5 or 3 years completion, so we used to do mid-year economic loss estimation due to this disease. And at the end of the program, so after 5th year, so we used to do this assessment of economic losses. And also we are planning to do what impact of vaccination program on controlling this disease. So so at the end of the program, so we'll come out with the figures which indicates what is the exact approximate economic loss due to this disease, and also what is the impact of this vaccination program on controlling this disease, and also saving the significant amount to the national execute, and also reducing the economic losses to the farmers, and in terms in increasing his farm income. So this is very important aspect in this classical swine fever control program. So economic loss estimation and also impact of vaccination on controlling this disease is very much important. So with this, I conclude my presentation. Thank you.
Thank you so much, sir, for providing a glimpse about the methods that need to be followed for assessment of economic loss due to CSF. Thank you so much for the informative presentation. So now it is the time for discussion. If you are having any specific questions related to CSF, we'll take up 2 to 3 questions because of the time shortage. So you can unmute yourself and ask the questions, please.
Dr. Siju, if they have any questions, they'll route through Dr. Gagan Deep, madam. You can go ahead, Dr. Siju.
Okay, sir. So thank you so much for all your presence for this meeting. So coming to the end of this session, we will be having a vote of thanks by Dr. R. Sridevi Madam, Senior Scientist, ICAR-NIVEDI. May I request Sridevi Madam to propose vote of thanks.
Thank you, Siju. Good afternoon all. On behalf of ICAR-NIVEDI, I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed for the conduction of this awareness program on SeroMonitoring of CSF classical swine fever control program under LH and DCP jointly by THAD, Government of India, New Delhi, and ICAR-NIVEDI. At the outset, I thank our director, Dr. B.R. Gulati, sir, for continued support and motivation. And I thank our director for emphasizing on importance of the classical swine fever disease and the biosecurity measures, vaccination, and the crucial roles and responsibilities of the field veterinarians in controlling and monitoring of the CSF to eradicate the disease by 2030. I also thank Dr. Rajiv Bali, Joint Director, NRDDL, Jalandhar, Punjab, for his remarks on the CSF control program implemented in the Punjab. I thank Dr. Parvinder Kaur, Assistant Director, NRDDL, Jalandhar, Punjab, for providing insights on classical swine fever in Punjab and also the occurrence of ASF in Punjab and the data on vaccination status of the CSF in Punjab. I thank Dr. Gursimran Philia, Principal Scientist, College of Veterinary Sciences, Gadwasu, Ludhiana, for giving a lecture on the research works which are carried out on the classical swine fever in Punjab and the investigations carried out by the College of Veterinary Sciences on the classical swine fever outbreaks in Punjab. I thank our Sir Dr. S.S. Patil, Principal Scientist and Nodal Officer, CSF CP Monitoring Program, and for giving complete insight on the control program which is to be implemented in all the states and the whole action plan and the and on the topics serum collection, labeling and sending, and for clear explanations on various aspects of the classical swine fever control program, surveillance and monitoring. I also thank our Dr. KP Suresh sir, Principal Scientist, for providing a sampling plan for all the control programs implemented by Government of India. I thank Dr. Jagdish Hiramat sir for overview on outbreak investigation and the steps involved in the outbreak investigation and emphasizing the importance of the steps and reporting the outbreaks in time for implementing the control measures. I thank Dr. Shiv Sharnappa, Senior Scientist, for pathological covering the pathological aspects and the how to differentiate between the classical swine fever and the African swine fever in the field conditions. I thank Dr. Narayanan, Senior Scientist, for covering the social network analysis, which is important for classical swine fever, pork and pork products related those aspects. And I thank Dr. Satish Gowda, Scientist, for covering the assessment of socioeconomic impact in Punjab in classical swine fever for classical swine fever disease. I also thank Dr. Siju Susan Jacob, Scientist, who has been anchoring this programs, and Dr. Chetan Kumar, who is a scientist and for rapporteur this whole session. And finally, a special thanks to organizing committee and all the staffs involved in this program for their support and coordination. And finally, all of our heartfelt thanks to the participants, that is the field veterinarians, who are the crucial players for whatever programs, even CSF, brucellosis, whatever community control program, they are the important crucial players for their active participation in this program. Thank you, one and all.
Dr. Sridevi, thanks to Arpita Gowda also, who is coordinating audiovisual aids.
Yes, sir. Yes, sir.
Thank you.
Thank you, Arpita.
Thank you, everyone. Thank you, Ji.
Thank you. Thank you, madam. Thank you.
Thank you, sir. Thank you very much.
Thank you, Philia, madam.
Thank you, sir. Thank you. Thank you to all.
Thank you.
Thank you. Makati das.
मैं उठ के गई
कहाँ गया?